map your success. Our expertise spans a wide array of services, including land use, land cover mapping, hazard mapping, various image processing techniques, hydrological and geostatistical analysis, and much more. Beyond project work, we are deeply committed to educations, offering extensive training programs and workshops designed to empower the next generations of geospatial professionals. We are incredibly proud of the journey we have embarked on with our learners. We have successfully completed several impactful courses, including our 3 months intensive program on the use of Python in geospatial applications. And we also recently concluded a highly successful training program on coastal resource modeling using geospatial techniques and basics of Google Earth Engine from scratch. We are currently running a 2 month hands-on training program on hyperspectral remote sensing using Prisma data. So thank you all for being here. We are confident that our webinar on GEO-AI for geospatial intelligence harnessing machine learning and deep learning and will be incredibly enriching and transformative experience for each one of you. So our guest or the resource person is with us. And now I would like to introduce our resource person, Sayantan Mondol. He's a SRF at the Department of Geography, Delhi School of Economics, University of Delhi. He completed his bachelor's degree in geography from Presidency University, where he graduated as a second topper of his batch. For his master's studies, he secured admission at several prestigious institutions, including IIPS, BHU, and DSE. He has successfully cleared the UGC NET GRF examination twice and was invited to deliver a topper stock interview at Byju's. His academic excellence is highlighted by receiving the first prize and best paper award, the prestigious INCRA conference organized by ISRO in Jodhpur 2023. He has published two research papers in reputed Q1 journals, with another paper accepting in the highly regarded Nature Portfolio scientific report, and several more in the pipeline. Sayantan has gained vast interdisciplinary research experience, having been selected for two DST respond workshops, one on glacier studies in Kashmir and another on military intelligence and remote sensing at DTU. Recently, he attended a prestigious, fully sponsored national workshop on extreme climatic event in Himalayas, organized by IIT Madras, held in Leh. So, this is a vivid introductions of our resource person. So, Sayantan sir, now the space is yours. You can take over the session. Thank you.
Okay, so am I audible to everyone? Please raise your hand or please tell those who are the
yes, sir, you are audible.
Okay, someone has raised the hands actually. Okay, Dr. Anju has, if there is any issue, you can talk or you can just raise your hand and tell, or you can tell in the chat also that if anything is needed or if any understanding is needed or not like that. Okay, so just wait for 1 second, I will start. Okay, so let's tell something that first of all, I want to introduce, my introduction has already been provided by them, but I don't want to introduce in that way, not in an academic format. I am just a PhD research scholar. Okay, so being a PhD research scholar is like I have just completed masters in 2021, and then I came here and in Delhi. I was also in Delhi also in 2019-21 as a master student, and after that I came into PhD. So it has been a lot of challenge for me. Okay, So at that time, 2021, there was no chat GPTs or anything like that. And when we started working with this type of fields, it just took me challenge. My supervisor asked me, Shanu, can you do this? And I told him that, yes, sir, let's try it. I don't know whether I will be able to go or not. Let's try it. So at that point of time, I just want to give you a very simple example that my research proposal was like bullet 350. I don't know anything, and my knowledge was like a unicycle. So it was a bit tussle, but I told myself that let's take a challenge. Okay, someone is telling that my voice is not clear. Is it true my voice is not clear?
Yes, sir, your voice is not clear.
Okay, so now it is clear?
No,
Now it is
sir.
okay?
It's echoing somewhat. It's echoing.
Okay. And what about the Shenzhen? Is it echoing?
Yeah, the voice is a little bit damp. So I think it is your.
Okay, just wait for 1 minute.
Yeah, yeah, sure.
Sir, if possible, you can use microphone as well.
Okay, just wait for 1 minute. Uh, See, now it is okay? Or is it still echoing?
Yes, sir. Now it's clear.
Now it is clear, everyone?
Yes, sir.
Yes,
Huh?
yes, clear.
Yes, sir.
Also, Purti, it is clear?
Yes, sir. Yes.
Okay. Actually, the problem is, let's see, this is also a part of a research. My laptop doesn't have a proper webcam, so I was using that is one mirror-based software known as UV cam or something like that, UV cam or something. So what happened is that I boosted the entire speaker's volume actually. So that's why it was being a bit echoed, but I didn't receive that thing. But thanks for telling me. Okay, so these are some of the technical glitches that we still face. Okay, so so basically, I just want to tell that whenever I have started this work on this PhD, so it was not like that a easy path. It was still a challenging, and it was a bit exploring. The thing is that you don't know everything, and then you are coming. You don't know everything, and then you are coming to PhD. If you know everything and come to PhD, then there is a no meaning of doing a PhD. Okay, so this is the thing. So basically, we will start with the with our topic, that is the applications of artificial intelligence, machine learning in the geospatial analysis, and this is actually one of the most current topic, and I think this is one of the most fruitful topic for the geographers and then the environmental scientists and everyone, because this is the future. Whatever I have learned from the last 2 3 years, that this is the future, and I will show you and I will tell you exactly that how being a geographer, because as majority people are from geography and other backgrounds who are allied to the geography, how we can get a secure future in this, how we can work in this, and what we can get from this what or this type of research actually, because this webinar is not a formality webinar. This is a webinar where you will be getting a lot of knowledge. A lot of knowledge of what? A lot of knowledge of what type of work we are doing, a knowledge of what is the current market status and where you stand, where your subject stand, and how our education system before the research has given you one position and how much you need to jump to be industry ready, to be a market ready. Okay. So it will be a bit long presentation. It is not a presentation, it is rather a journey. The journey I will show you through presentations, but I will also give you some of the good examples about it. I have a lot of my seniors, lot of my colleagues who are in foreign, who are in India also, those who are doing work, and how we can better ourselves to match their standards. And I will tell you all everything. So just keep one pen and paper with you. Okay. So if you find anything, just check like a running notes. It's not like you have to take everything. Just a few of the things like about what I am talking about what are the pathways. So be ready with that. So we will start within 1 or 2 minutes. Okay. So keep a pen and a pencil, a pen and a paper with you, or a pencil and a paper with you, and then we will start. So now it is okay. So actually, am I audible? It is clear now.
Yes, sir. Perfectly audible.
Okay. Just wait for 1 minute. Huh. So I am sharing my screen then. That's like PowerPoint presentation. Okay, and one of the most important and interesting thing is that in this entire presentation, I will also provide you one hands-on training. So what is this hands-on training? I will provide you one software. It is already open source and many of you don't know. So because if you want to work on this type of machine learning things, then you will be needing this type of software so that it can help you a lot. It will save your time. It will save your computational time also. So and I will gradually tell you what are the things that we will be showing. So this is not just a mere workshop. I will tell you this is a very special workshop for me. I returned yesterday from the Ladakh. I was in a workshop there, and just within one day, I have to make this PPT. I could have made it much better, but whatever I have made, I know it will be more than enough for you. But if I have got some time, I could have made it a bit better, more interesting. Okay, so let's start it. Okay, so I'm just sharing my screen. Presentation is starting. The entire screen. Share. Okay, so just tell me that whether my screen is sharing or not. It is sharing?
Yes, it is
Yes?
visible.
Yes, sir. Yes, sir.
The first page. Okay, everyone, just tell me yes or no. Just tell me anyone. Just tell me yes or no. Okay, okay, okay. Fine,
Yes,
fine.
sir.
Sorry, but as the thing is that I am not observing this page actually. So that's why I couldn't know that whether my page is visible or not. Okay, so okay, let's start. So this is our first page. It clearly shows that it's a GEO-AI for geospatial intelligence, harnessing machine learning and deep learning techniques. Okay. So basically, before jumping to direct machine learning and deep learning, because it sounds cool, it is in the era of an AI, let's first take a dive on this part that why this machine learning is needed for a GIS. Because till I remember, till 2018 or 19, when I was in the graduation at Presidency University, we had never experienced this type of machine learning. But though we were using one of the machine learning algorithm, like for example, many of you have done LULC, that is land use land cover changes. So in LULC, if you use ArcGIS that is before 10.8, you will definitely find that you are using an MLR, that is the maximum likelihood classifier. Okay, MLC. Okay, maximum likelihood classifier as the algorithm for LULC classification. That is also a part of an ML, but we didn't know at that time. But now when we are studying these algorithms, and this algorithmic studies are telling us that these are all the small part that are the integrations of an machine learning that we don't used to know. We are using that, we don't used to know. Okay. So another important thing is, suppose you are watching a Netflix or buying a product. Okay. So when you are carting one product, you will find in your advertising there are similar products are there. These are all because of the machine learning, because the machine is constantly reading your data, that what type of products you are watching, you are searching, you are observing. Okay, and then when you are going to on a different platform like Facebook and Instagram, this type of ads are again coming to. So this behavioral analytics is a part of a machine learning, because they are leveraging the products. Okay, so why machine learning is important in today's world is that because it helps in business. Anything that helps in business innovation is the market trend. Okay, for example, I know machine learning. You know machine learning algorithms and everything, but until and unless you are making a product out of it, we call it MLOps. That is machine learning operation pipelines. Okay? So until and unless you are making an MLOps, it will not fetch you money. Because suppose I was looking for a cargo pant, okay, in Myntra. I found it, I carted few of it, but I didn't like it. I moved to Facebook. After a few minutes, I found that some of the other cargo pants with great discounts are coming into Facebook. What is happening? Okay, I got this one here. Let's click on it. So I click on it and then I cart it and then I buy it. In this way, see, if that machine learning ops, that is ML was not present, and if the ad has not been shown on the Facebook or the Instagram, I couldn't have buy it, or I shouldn't have buy it, but because that was there with a great discount, so I buy it. So in this way, this MLOps is actually turning these potential customers into a customer actually. From potentiality to the entire business, they are making it. So in this way, machine learning is important. I'm just provided you one example. There are thousands of examples. For example, one of the highest grossing MLOps engineers are from the Netflix. Okay. So Netflix, what happens? The more you see a movie on a Netflix, the more is the watch time, and the more is the watch time, the more they get the money and they earn the money. So what happens when you suppose you are watching a movie on a war? Okay, I am a great lover of war movies. So in the Second World War, First World War. So after watching one war movie, after that, the few of the next few movies that will be recommended will be on the war movies, so that it will try you to engage more and more into their softwares or more into more of their interfaces, so they can earn a more money. So see, because of this MLOps only, they are getting more money because they are producing more money because they are directly influencing the behavior of the consumers. Okay, so these are all the MLOps in real life. That's a lot of money. Okay, but these are not restricted to only to the ML engineers and AI engineers. And the one of the most important things I want to tell each and everyone is AI is the field where it is a level playing field. That means a computer science engineer, a geographer with a knowledge of GIS, a civil engineer, and a computer and an MSc in computer science, they all are equal in front of an AI. Because a CSE can make a software, but they can't be an AI engineer. Okay, so they need to study for that. A geographer can be a very good at GIS, but they can't be an AI engineer. They have to study for that. Okay, a civil, that is a completely different background, but still people are coming from civil engineers to be a part of an AI engineer. So see, this is a very good level playing field for each and everyone. Okay, so if you observe the LinkedIn post of the Adobe's, FANGs, especially FANGs and Adobe's, FANGs with Facebook, Amazon, Microsoft, Netflix, Google, and then there are other like Adobe's, NVIDIA's are there actually. So in this type of companies, they ask that they don't need only BTech students. They tell that, are you aware of this machine learning? Are you aware of this AI? How much work experience you have in this AI and machine learning? And then they provide some of the list of fields that are need to be tick marked, that your skill should be aligned with this one, and then you will be hired. There is a no question or barrier on whether you are from a BTech or you are geography, because a BTech in CSE will not know AI. So there was a separate discipline came in this new BTech courses, that is the engineering in AI and machine learning. Okay, so so this is a time where each and everyone has a very good level playing field. If you can master this, you can get a very good job. Okay, I will tell you one recent example that I have also given one CV to the ISRI, that is the company that have produced the ArcGIS, and I got a call from that interview and given a technical test also. I will share with you all that how these things happen and how as a geographers we can get into a corporate sector and get a good job that are aligned to our field only. That is not, we're not completely switching our field and going, but we're aligning. Okay, before that, let's start with, I'm giving a lot of lectures. Okay, so let's start with the main thing. Okay. So today there is a very big important word, that is GEO-AI for geospatial intelligence. Okay, what is GEO? That is geo comes from the geography and AI is the artificial intelligence. So basically what GEO-AI is doing, whatever the geographical work we are doing, we are integrating with the artificial intelligence. Okay. You can see this is the thing, geospatial science integrating with AI and machine learning, because nowadays a lot of paper are there coming in the GEO-AI. I have also 2 paper in this GEO-AI field. That's why this terminology has been an important. So why GEO-AI is required? Okay. So GIS was there. So see, in the traditional methods, we have a static output. Okay. Static, there are some output maps, there are some time inverse analysis or time series analysis are there. Okay. But we used to create maps. So as a geographer, we used to think that we are the founder, father, and everything of the GIS, only we know GIS. At the beginning, I used to think like that only. Okay, each and every geographer think like that. But when I get exposed to other fields, I think, oh my God, geographers are still static. We are still creating one map and we are still quarreling whether the legends are on the bottom or the legends will be on the side or whether the heading will be on the top, why the north arrow is like this, why the north arrow is like that. We are quarreling with the wrong. We would have at that point of time, instead of quarreling of how beautiful a map looks, we should have looked into how productive our map is. That is the most important thing. But nowadays, still I find a lot of people still, some of the people, professionals are querying why your map has a legend in this way, why your map has that in that way. Okay. They will never ask or they are never interested in the productivity of the map. That what type of map you are making? Is this a prediction map? Is it a classifier map? Or is this map solving any problem in today's world? No one is talking like that. Okay. So I have faced a lot of difficulties in this, and I have protested against this, and I haven't got some good support. I was on in a geography conferences back in Osmania University. I found this type of questions that I why your north arrow was downward, and I couldn't even explain him, and couldn't even persuaded him that my map was a 3D and it is a southern phase. That's why the north arrow automatically pointed downward. Okay, so people are quarreling with the downward of the arrow, but they are not talking with the productivity of the map. That is the most important thing that I will tell you, because in the corporate world, it is all the productivity of your work, that what map or what information is coming out from your spatial analysis that will fetch you a good amount of money. Okay, this is the most important thing that you all need to learn. But see, when we are shifted to the GEO-AI, there is an automation. So what is an automation? It is a pipeline that you provide one data. I will show you and I will provide you one example, a very good example of my work. See, whatever work I will show you, 99% work is of mine. Okay. And rest 1%, that is 1% is the work of one of my colleagues with whom I have collaborated and helped him to do that. Okay. So this is the thing. So when we are shifting to GEO-AI, what's happening is first in the automation of a complex task. That means you are making a tough pipeline. So whenever the next person will be doing that work, he will not do it from the scratch. He will take that pipeline and he will just change the location to get that data. Okay, that is the one part. Second is the predictive modeling and forecasting. I will show you what type of predictive modeling and forecasting we have done. Third is the handling a real-time and dynamic data. And I will give you one futuristic plan of a real-time dynamic data, because getting a real-time dynamic data is a big problem with a very less fund. But if you have a more fund, you can work on this part. And I have a huge plan on working on this one. I have already started working on this type of plans also. And there is a scalability of a large-scale analysis. Okay? Scalability of a large-scale analysis means suppose you have made a forecasting mechanism that if a rainfall occurs from a particular place and the discharge of the water is going downward, and on the downward side of the hill slopes or the valley, there is a settlement. And if the settlement is there, then how much flood water will flow through? So you have made the entire mechanism. Okay. So what you will have to do, you will just change the location and precipitation so that it can be scalable to the other areas. Okay. Provided there are some terms and conditions there that I will explain you later. Okay. So these are the things. I hope you are getting my point. So first thing is I just want to ask all of you whether I am audible clear or not, and whether you are able to understand my words or not, because I am telling in a very simple English. And if you face any problem, you can tell me. Okay. So are you understanding what I am trying to tell you? What I am trying to tell you? Are you?
Yes, sir. Yes, sir.
Yes.
Okay. 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 And if you feel bored, please tell me. Then I will make some of the things with experiences and make a little bit entertaining. Okay. Sometimes it is a bit monotonous, but sometimes it is not also. Okay. So this is a simple presentation, and this presentation has been made by the Gemini. Okay. The entire diagrams have been made by Gemini. This one, this one. So this manual GIS, GEO-AI, everything, this has been done by Gemini. It is not like I have made a presentation out of it. I just told Gemini to make an HTML interactive web application of it. And they have made a very beautiful web application for me. And I will also tell you how I have made it at the end of this presentation, that then you can also create a very good, clean, proper presentation, like few pages. I have not taken all the pages from the Gemini. There's some few pages are there. The rest of my research pages. Okay. So see, this is the thing. I have provided him the information that I want a traditional way and a new way to show that why manual GIS and GEO are different, and they made this. See, this entire presentation's first few slides, like first five slides or 6 slides are being made by the AI. Okay, see how AI is linked with us. See what it is. There is a manual and static part. That is, we in this part of this research, for example, you are making a map. You are making a crop map. Okay, the map we used to see in the geography books in class 10, 11, 12. That is Kharif crop, Rabi crop, wheat, bajra. So that relies on the human interpretation. Okay, like static map. But when we are coming to GEO-AI, we are making LULC. The first thing that comes to your mind is that LULC, a land use land classifier. You are taking some samples, you are providing and assigning some values, and on the basis of the samples, they are giving the entire map or the entire data into an LULC. So that is, they are automatically detecting the pattern, provided that we are giving some of the good sample data sets. Okay. So these are the part of the GEO, and I hope each and every one, those who are here, they can easily understand that how these things are offered. So these are not that much complex. See, don't get nervous by the word GEO-AI. Oh my God, it's a very big term. No, that is not like that. Yes, there are very much big complexities are there also, but don't get so much like, oh, that person is working on GEO-AI. See, I can work on an LULC map in an ArcGIS 10.8 using SVA, that is support vector machine, instead of maximum level classifier. And I can tell you that I have used GEO-AI in this LULC mapping. Okay, but that is not a high standard work actually, basically, because maximum level classifier also a part of an ML that we have used in ArcGIS 10.4, 10.2 version when we were in 2016 and 17. Just because we don't know the words, don't get deserted or don't get demotivated like that. Okay. So we all have come here to learn. We all have come here to understand. Even some of the top-notch AI engineers are also learning each and every day. We are also learning each and every day. You are also learning each and every day. So don't get deserted and don't get that much overwhelmed, and also don't find these PPTs or this webinar as, oh my God, it has so much thing. I have not done anything. See, it also took me 2 to 3 years to be in this position to make this type of presentations. Okay, so it will take time, because every good thing takes time. Rome was not built in a single day. This is the first thing that I will tell. Always open up to new learning. Okay, and at the before that, Shinchan was talking about by giving my intro that I have given 2 times net this. Yes, that is okay, but the harsh reality in today's world is the clearing net GRF examination has nothing to do with the doing research. Okay, you can be a topper in a net GRF, but you can be dumb in a research. You can be just cleared net GRF, or you couldn't even clear net GRF, and you can still become one of the finest researchers. Okay, that one examination doesn't make you think like, because you will find a lot of people around you. Oh, he's the net GRF candidate. Who is that? Who is that? Oh, see, that is one phase of a life. Okay. So just because you are a first boy or a first girl in your college, that doesn't mean you will be a very good researcher also. Okay, so what is the thing is that what you are today, what you are at the present is mattering the most. Okay, this is the thing. Suppose I have cleared my net GRF in 2020. Okay, it has almost been 5 years. See, I was in the master's first year, almost been 5 years. And if I have not done this type of research, what will be the last achievement that I could have told? Oh, I have cleared net GRF in my master's in my first attempt in 2020. After that, nothing. I have not done nothing. Okay. But today, I have a lot of things to take. I have a lot of things to share, a lot of achievements to share, and a lot of innovations to share. So that clearing a net GRF has faded from my memory. Okay, that is a part of a life. Only we need to get some money to, so that we can sustain ourselves or we get PhD in one of the most expensive cities like Delhi. Okay, so that is the thing. So don't get disappointed. I am always there to motivate each and every one. Okay, just stay motivated, do your work, and you will find everything on your way. Okay, so see, this is a real-time dynamic data example. We are using satellite imagery. I will tell you one example. Satellite imagery IoT sensors, and social media fields. These are real-time dynamic data. So in satellite imagery, what type of data we can get? We can get a synthetic aperture radar data. We can get a DEM data. We can get a Landsat data. We can get a Sentinel-2 satellite images. We can get a planet data of 3-meter resolution or a quick but of a 1-meter resolution data. So these are satellite images. Then there are IoT sensors. The question is, what are these IoT sensors? IoT means Internet of Things. Internet of Things occurs like, for example, this is a machine. Okay, suppose this is a machine. What does this machine work? When I put this machine near in the terrace, it will calculate the precipitation. Then how much precipitation per hour it is occurring, and it will provide this precipitation to the cloud server. A cloud server through which I can get a continuous data. So it is like an edge computing. It is a data, it is a machine, it is collecting a data and storing in its arena, and I am collecting that data from that arena. Okay, so this is IoT sensors. For example, people who are working on the floods, they used to get a lot of discharge data. For example, in a dam. So in a dam, there are a lot of discharge data people can get. From where these people are getting this discharge data? They are getting from the IoT sensors. Okay, and I will also provide you some of the other examples of the IoT sensors, okay, that we have used in our life. And last is social media feeds. Okay, now this is very interesting thing that what is a social media feed is actually what happens here. We can do it this way. There is a futuristic proposal also that suppose when there is an earthquake, everyone tells and everyone clicks that mark safe, that the earthquake occurred in my area and I have marked it safe, that I am safe. Okay, so for some people it is like roasting see whatever silly things that they are doing. No, these are not silly things actually, because when a person is clicking by standing on his area and marking safe, and a people of 50 to 30, 60 people are standing around surrounding him and also clicking on the marking safe, that means the phone's GPS is geotagged. When they are taking mark safe, an entire map is created of a hotspot where people are safe after that earthquake, where people are not safe. Okay, if someone got stuck in a building and they can't came out and they got some space and they are clicking that I am not safe here, that means what is happening at that hotspot, there are a lot of damages the building are there and people are still alive and they need excavation. These are known as the community GIS actually. Then we are fetching the real-time data from the communities. So in social media field, there are marks safe from the floods. So with the help of the mark safe from the flood, we can delineate that zone that where people are safe and where people are not safe actually. So these things are important. It's not only for yourself, but also for the society and also for the disaster management team to understand that where people are safe and people are not safe. So I think you are getting all my point. So can you align with this? These are some real life scenarios. Can you align with this, what I am telling? If not, then I can give you much simpler examples also. Are you understanding? Just tell me once. Anyone? Are you getting aligned with this work? This type of?
Yes,
See?
sir. Yes, sir.
Okay.
Yes, sir.
Okay. See, I am a bit insecure while teaching online actually, because I always prefer an offline meeting, but teaching online, I am always insecure because I don't know whether I am still telling and signal got lost and I am continuously speaking. Okay. So I feel a bit insecure. So that's why I kept you asking. And this also helps us to engage. Okay. So let's come to my study area. Okay. This is a study area of mine. This is a work that I have done on the Chamoli district. Okay. So my study area is this, and you can see there are a lot of landslide points. You can see there are a lot of landslide points are there. If you can see my mouse here, you can easily tell you. So this type of maps we have quite commonly seen. So how you can advance with GIS? Okay. So these are some of the landslide points. This is the Indian map. This is Uttarakhand. What you can do is, I have done in one of my papers, is that instead of giving this map, because each and everyone is making this, how you can be different. I have used this one. So what is this? See, these both are the same map, but here you can find there is a blue color kernel density. So what is this kernel density? See, we are simply using the spatial statistics. Kernel density is that where the number of landslides are very high within a per unit area. Basically, density is that number of occurrences per unit area is the density. So you can see from here that instead of just only providing this number of landslide points and this Chamoli district study area map, we can provide a very good kernel density map also in the study area. It will show that how this person has acquired these spatial skills, spatial and statistical skills to represent. So this map is not showing that where the number of landslides are there, but this map is also showing that the kernel densities also, that where the occurrences of this landslide inventories are very high. So these are some of the examples that I want to show you that how you can advance from the step by step in AI and machine learning. See, AI and machine learning begins with a very common thing, that is statistics. Without statistics, no AI machine learning can occur. Okay, so you need to have some you need to know some statistics. That is the first part. Second part is that along with statistics, there is an important thing called probability. Probability is also a very important thing. Unless you're understanding the probability, you can't be able to work on this AI and machine learning, especially not in the part of classifier, but in the part of predictions and forecasting actually. Okay, so these are some of the parameters that you will create. I have also created in the GIS software, and as a geographer, we are all aligned to this thing. Okay, we have made this altitude map, we made this geology map, but what to do with this map? Just representing them together there on the with good legends and everything. It's not everything that we need to work on much better thing. So what are these better things? Sir? Okay, first we have to understand that we have made this 10. Suppose there are 10 maps are there. What fruitful things can we make from this 10 maps? Some of the traditional methods have shown us overlay analysis, multi-criteria decision making, or an analytical hierarchical process through which we can give a weights to each and every parameters and we can finally get an answer. But when we are coming to the machine learning algorithm, in the machine learning algorithm, what happens is that we are working more on this, combining this entire work, blending it, and we are providing the final. Before going to that, I just want to show you, this is a bibliometric analysis. So what is the bibliometric analysis? Is the what type of studies that are going on in this field is also not a bibliometric study. So see, there is a trend of machine learning that started from 2001 to 2022, and you see that in 2001, there is only one paper was there. But there are a lot of papers in this type of field. A huge paper that came in 2022. But if you see the recent trends of ML in geospatial analysis, you will find that from 2017 to 23, a lot of people have started working on this machine learning. So why this trend has increased? Because we started to understand the productivity of these geospatial analysis, and integrating the AI in it will deeply benefit the entire society. That's why the number of people has also increased in this machine learning. Okay, so before there was a huge trend in my field, that is geography. What happened that people those who used to study the physical geography, they tend to think into superior. They are human geographers, we are physical geographers. And among these physical geographers, there are the two branches that think they are the superior among these physical geographers. One is fluvial geomorphologist and one is geomorphologist. Okay, so these are the top two hierarchical trends that used to dominate. But unfortunately, with the advent of an AI/ML, each and every field, even in the human field, I have also worked on it. Even in the economic field, I have also worked on it. I have used artificial intelligence, and they can give a superior result. So these hierarchies start to get diminished, because the more we grow, we know that the way AI is increasing, the way GIS has been gone to various fields, it is ultimately the interdisciplinary knowledge, that integration and collaboration with each and every field can give you a much better result. So these modern problems can be solved with these modern solutions by collaboration. So we are there to reduce the hierarchies among the people those are working it, because a civil engineer is also working on an AI, a mechanical engineer is also working on AI, a computer science engineer is CSE is also working on the AI, and as a geographer we are also working in AI, and each and every one has been given an equal importance to it. For example, I just want to ensure one short thing that I visited few days back in May. Just I came the day before yesterday. So there were a lot of people from the other backgrounds, like civil engineers, some of from the top-notch cohort institutes like IIT Madras, that is this time NIRF rank 1 university, that is, then some are from the astrophysics from Bangalore, then there are some from the IIT Kharagpur, and I am just a simple geographer who has also been selected. The thing is that when I visited there, I saw that we are all knowing something that each of us don't know. So we are sharing with each other. We are collaborating with each other. We are sharing the ideas with each other. And there is no hierarchy in it. This is the beauty of this AI that has made that each and every domain that used to feel that we are the top cohort, we are the superior, has all come in the same level playing field. So if you can learn this thing, nobody can tell you whether you are a physical geographer or whether you are not a geomorphologist, not a fluvial geographer, even if you are a human geographer also, you will get the same opportunity to collaborate, you will get the same values and same prestige that other cohort disciplines also provide. Okay, so I just want to tell this thing. Okay, so we can see that these are the parameters that we have created, and these are the data sources. See, these are all the same data sources for the machine learning that we used to do for our static data also. For the slope, aspect, curvature, we can be done using a DEM, from which DEM we are using SRTM DEM. Now you can see the last two columns. These are the tolerance and VIF. So this VIF and tolerance. What does this VIF mean? There is variance information function fractions and there is tolerances. So basically, suppose you have 17 to 18 parameters. So with the help of this type of parameters, when you are working, these are big data because we are talking huge number of pixels to it. To work with that, we need to understand that whether whichever parameters that we have created, are all these parameters required for our classification or not. For example, suppose you have a slope and you have a power slope. Both slope and power slope more or less similar to each other. Means their R square value is near 1. Okay. So then what will happen? That one factor will try to influence twice, either slope or slope power. Okay, it will try to influence twice. So we do a tolerance and VIF check. So VIF less than 5 is very good, and tolerance more than 0.1 is also considered very good. So simultaneously we have to see that VIF of each parameter should be less than 5 or less than 10, and tolerance should be more than 0.1, so that there is no multicollinearity among the variables. So I have seen a lot of people working on these machine learning algorithms and not getting a very good result because they are not doing this tolerance and VIF check. For example, if in this triggering factors in this table, you will find that if aspect is having a tolerance instead of 0.9, it is having a tolerance less than 0.1, and VIF is more than 5 or more than 6. I will not be using this aspect in my calculations because it will create a multicollinearity problem. Okay, so to understand this multicollinearity, you have to understand the statistics. That you need to know the regression, you need to know the R square, you need to know the coefficient of variation, standard deviation. Then we need to correlations. Okay, then you can understand this multicollinearity analysis. So see, from this very beginning, I just want to tell that don't jump anything that is sounds trendy. First, learn the basics, because until and unless you are learning the basics, directly jumping will also push you in the edge of a river, because you can't tolerate, you can withstand that pressure of that concept. Because until and unless you are learning from the very beginning, so it will create a resilient. Okay, whatever statistical techniques and methodologies are there, I can handle it because I have learned all the basics. Okay, this is the most important thing that I just want to tell you. Okay. So this is just an introduction to AI and how this AI ML look like. For example, suppose we have 18 parameters. These are all the parameters. These are all the hidden layers in a machine learning through which it will be connecting with each other. This one is going here, this one is going here, and again it is coming here. So in this way, there is a forward and backward propagation that is going on in this entire ML algorithm, and ultimately it is giving two options. For here, the output I have made in two ways. Either the occurrence is true or the occurrence is false. Okay. In this way, we are classifying our near forecast. So this is one of the very basic examples of a machine learning, because in a 1.5 hour or 2.5 hours seminar, we just can't explain the entire machine learning because it takes 3 years, 4 years to learn, and to explain it is not that much easy. I have to then explain it from the very beginning that what's happening and what's not happening. You can see this all those things in a YouTube channel. So there are a lot of they're teaching this machine learning from the very beginning. You can see that I'm just giving an overview how we can use it in GIS. Thing is that why you are watching this webinar, because you will not find this type of things in YouTube. Because in YouTube you will find a lot of machine learning courses and everything, and machine learning overviews and videos, but not in terms of the GIS. Because integrating spatial information with machine learning is difficult, and it is still getting a lot of exploration, and still there are very few or no videos present that can properly give you an entire idea of AI and machine learning in geospatial analysis. So these are the things that you need to take care of. That's why you are joining. So I need to provide you something special so that you are spending this much of 2.5 hours of your crucial time to this webinar. That is also just before the festival season is starting, and you are not going to buy new clothes and you are sitting here observing this webinar. So this webinar also needs to provide you in value, to provide you some good value that you can learn today. Okay. So these are some of the diagrams that I've shown you in the introduction of an AI/ML. I have worked on this one, and you can see these are some of the neural network architecture. The first, let's start from the NLP. This is one of the very basic neural network structure. We call it a multi-layer perceptron neural network. You can see that 4 layers is there. The last layer is the output layer, and 2 hidden layer and 1 input layer. Then we can see an XGBoost. Okay. This XGBoost is also one of the extra gradient boosting algorithm. This is one of the finest algorithms I've ever used, because when no deep learning or machine learning runs properly, XGBoost always runs. It is always a savior for us. And you can see that each and every XGBoost is combined with tree. These trees are known as the decision trees. These are the architecture. You will not find a proper XGBoost architecture in the market. So we have created this architecture, and we have uploaded this in our paper also. You can find in Google this type of picture that we have created. So here you can see that suppose we have n number of input. So you can see there is input number 1, input number 2 in the XGBoost, and then there are n number of input. Each and every input is passed through one of the decision tree. Decision tree itself is one of the machine learning model. And here all these decision trees are assembled together. Ensemble means they're assembled together, just like an Avengers got assembled. Here they are also getting assembled together, and we are getting some final results. So the final results here is the sum of the results they are providing, and when we do an ML ensemble, we do a logistic integration. I will tell you that in the next stage. Okay, so this is the XGBoost, and then there is an ML plane, and in the top you will find the network structure of a dense neural network, because this is not a simple neural network. Each and neural network is connected with a lot of square. You can see. You can see around 128 squares here, 18 squares here, 18 these are 18 parameters, then there are 4 neural depth, 5 neural depth. Each and every neural depth are connected in one output layer. So that's why this is a dense net neural network, one of the most prominent neural network for image classification and for the focus. Okay. So for example, this is an image that I have created. So this is basically a landslide susceptibility map of Chamoli district. I'm sorry I couldn't write everything properly here because of my rush hour. But this is a landslide susceptibility map, and you can see the red areas are the prominent areas that have been predicted as the most susceptible areas prone to landslides. Okay, and this is the first map is of the dense neural network map. The second map is of the ML map, and third one is the XGBoost. So 3 different models have provided 3 different layers of the map. Okay, so based on these maps, we also got some accuracy assessment. These are some accuracy assessment. What are these accuracy assessment? These are all the these are known as the K-fold accuracies. Because first one is known as the AUC ROC curve. You can see this one. This is area under the receiver's operating curve. For example, I know it is giving a much more complex things to you. Just try to understand in a simple way. When you are doing NULC map, land use landform map, you do a kappa coefficient to see how much percentage of your NULC maps are correct. 80%, 85%, 90%. In this way, to assess the accuracy of this model, that how this model has been accurated or has been created, whether it has been underdeveloped model or an underfitted model or an overfitted model. So we need to do an AUC ROC check, that how much area under curve is there. If this AUC curve is more than 0.85, more than 0.9, it's a very good model. So it can be reliable. Similarly, SIRF one accuracy assessment cannot be the only sole criteria to assess whether the model is good or not. Then there are other things like F1 score is there, precision recall is there. With the help of that, which I will tell you with data set how we collect this F1 precision and recall and how they are helping us to understand whether this model is good or not. So an F1 score of around 0.85, 0.86 is a very good model. That means the model is quite accurate. Then if we provide these maps also, see, you can see the 3 map is there and you can see this accuracy assessment is there. This is not enough because this accuracy assessment is of the model. So what we need to do is we need to show some ground proof that I need to go to visit the ground. I need to have a rigorous field investigation to see that whether if the places where they are showing red, are these areas really susceptible to landslide? Are there any past landslide occurred in that area or not? For that, we have to do another ground-based exploration and classification to provide a robust validation of this entire work. That, so see, you are creating a map, then you are creating this AUC, ROC curve or accuracy assessment graphs to prove that whether the model is running correctly or not. So model can run very good and very correct, but whether that thing is aligning with the ground or not, then you have to check that and you have to show their accuracy also. Then the paper will get published. Otherwise, reviewer will ask, what is your ground accuracy? You have made a model, your model might be overfitted, you got a very good, if you are getting 95, 96% of accuracy, there is 0.95, 97 AUC, ROC card, there is a high chance that model has been overfitted. So getting a high accuracy on this model accuracy is also not providing the real picture that is occurring on the ground. Because ultimate motto of running ML, AI ML is to replicate, okay, to replicate what is actually occurring on the ground. If we can't capture the ground scenario, what is the need of an AI ML? So we need to keep doing these things within. Okay, so are you getting my point? Am I able to understand you that what is going on in today's market? Please tell me. Yes or no? Please.
Yes, sir.
Yes, sir.
getting?
Trying to understand.
Trying to understand. That's a very good response I find, because he has not told, yes, I have understood, and he has not told that I am not understood. This is a very good, this is the realism. See, the thing is that if you told you have understood, then the AUC ROC value would have been gone beyond 0.95. And if you told I have not understood, your AUC ROC value is based on the decision we have come to below 0.5. And you told that I'm trying to understand. That means your value lies is 0.8 to 0.9. This is a very good realistic example. See, with your response, I am telling you this is a realistic example. You can't learn, can't know, or can't learn everything in a single webinar. But you can have some ideas that you can explore later on. And with exploring later on, you can be in this position where am I, and in future, I want each and everyone to surpass me and go beyond me, and you can provide me information that, sir or bhaiya, I have known this thing, and how do you assess this, or how do you think that this idea can be replicated on the ground? Okay, so this, then I will be very much satisfied that, okay, those who have given one lecture or one pep talk, they have surpassed me in future. Okay, so these are the things. The way you express that trying to learn is an accuracy assessment between 0.8 to 0.9. It is not beyond 9, because then it will be overestimated. Okay, so I think now you have got with one of the example from your side. So see, from this map, I have taken this one. Is dense state neural network. Can you see this mouse? This is the image number A, and I have put this image A here. This is my image A, and I have shown them the ground truth. From here, I have shown there the map here. This is the satellite image, and I visited this place. I have all the lat longs provided here. Similarly, in this map also, I have shown in this map what has happened. This is the region this is map is showing, and these are some of the places in red mark where landslide has occurred, and I have visited that place to show the ground to the, yes, I have visited that place. There is a lat long. You can see this lat long here, or as well as here, and you can find out the results are quite matched. These are one of the robust ground accuracies that can be done through visual. There are other ways also like binary AUC, ROC graph that we have introduced for the first time. That was our Nobel Award in our entire field of research. And in the geospatial analysis, we are the first one in the entire publishing history to create an AUC ROC binary card to provide that how ground truth is matched with the model's outcome. Okay, I'll show you one paper after the end of this webinar where we have introduced that one, and it has got a very good response actually. Okay, so coming to the next part. So you can see that these are some of the outcomes of this map to show that the places where market in genuine they have some of these event occurrences. Okay. So now this is one of the most interesting maps that I have drawn. I just want to show you that this image, that image A and image B, I got this paper on the nature publications in the Nature scientific reports. What happened is that I have predicted one susceptibility, but after susceptibility, I used a set theory of mathematics to integrate all the models together to get a final output. And in 2023, I found that this region, you can see in image B, a GPS mark is given. It has shown a very high landslide is very high, and the green region shows very high. It shows high landslide zonation, and red area shows very high landslide zonation. In the red area, I have taken photographs. These are all my photographs I have taken in 2023. Okay, in the August-September time, in September in 2023, if you go there, tunnel, and in 2024, that landslide occurred. So I have completed this paper in 2023, and this has occurred in 2024. Within 1 year, one of my predictions got converted into the occurrences. Okay, so you can see it is exactly almost 1 year after that particular landslides occurred on that region. So you can see that how this landslide susceptibility map is actually providing the scenarios that what we are predicting even within 1 year, the things are occurring. Okay, these are the event occurrences, and this shows how successful our model is. So these are the validations. Okay, so I hope you got to understand the scenario actually. So these are quite interesting things that I visited the place, and after 1 year, the entire tunnel got vanished because I have taken this photo by standing here, and the very big this has gone into the debris. Okay, Acha. So coming to the next part, this is another arena of a geospatial analysis, and this is known as segment anything model. So this segment anything model was introduced in 2022 by a very well-known professor from Tennessee University, USA. Digitization. For example, you need to digitize the buildings. Then suppose there are 2,000 to 3,000 buildings, and it's a quite monotonous to digitize each and every building, creating shape files of that building, and then working on it. So what happened is that I have integrated the computer vision technology with geospatial analysis. You can see this is the raw satellite image of a link map satellite images. Okay, it's a raw image. I have used the model of segment anything model, and I have created this one. Okay, this raw images actually. Then I have segmented it, and then I masked it, and I called a TIFF file, and then I converted this TIFF file into the shape file, and I've taken out all the building footprints without even digitizing a single thing within a span of 10 minutes. The thing which would have taken me 1 day or 2 dedicated days of workforce to collect around 1,100 or 1,200 buildings, I have done it within 10 minutes. This is the power of an AI. So AI is not for publishing paper. First of all, AI is there to reduce your work. So I've shown that one in this paper, also this nature paper, that how I have used this segment anything model, and this model's code is also there in also this open source. And actually, I will show you. I just want to show you how this model has run actually. So let me see if I have found something like that. So I just want to tell you one thing, that after masking this all this files, and you can see that I have masked it 6 different ways. You can ask the question that, so why you have taken 6 separate batches to mask the buildings, and why not in a single you have collected each and every one? Because computational force will be very high to capture one in a single. it takes a lot of GPU power, and in Google Colab, GPU power is not that much high. So I have to do some batch processing. These are batch by batch. I have collected the data and I have used it for my work actually. And see, if you want to see the end product, these are the end products of these buildings. You can see these are the end product. I then converted this into 3D buildings. Here I have the building information heights, and then see, I have extracted the building using computer vision, and I have made a 3D model out of that. Okay, so are you getting this thing? See how interesting it is. It is very,
Hello,
very
sir.
interesting. Hello, yes, tell me.
Sorry for interruption, sir.
Yes,
Lots of questions are in chat box, sir. Please let me.
Okay. Wait for 1 minute. Sorry. I just want to. Oh, I'm just going to check. Okay, wait for 1 minute. Okay. So show my screen anyway. Acha, there are chat box.
Sir, you can refer to the Q&A section.
I have gone. You can see that these are the things. Okay. Can you see my screen? Is it visible? My screen is visible. Hello.
No, right now it is freezed.
Acha, okay, just wait for 1 minute. Okay. Now the screen are visible?
Yes.
Okay. I know it somewhat got somewhere it got stuck actually. So you can see that here there are some of the question is there.
Okay, I will repeat the questions for you. There is one question.
Please repeat the question. Please repeat the question.
Yeah. So there is some question from by Rakesh Samanto. So he is telling that, sir, please tell again why we use the tolerance value.
Please tell why we use. Acha, okay. So for example, you want to send some money to your friend. Okay. So first you go to PhonePe, then you provide your fingerprint or your code, and then you enter the PhonePe. That is the first set of security, and your second set of security is when you send the money, you provide the UPI key. Okay. So to do the multi-collinearity check, only looking to the VIF will not be enough. Okay. So we have to look on the tolerances also. That whether the tolerance value is more than 0.1, then we will select each and every one, and if VIF value is less than 10 or less than 5. Okay. So this is the thing. This is the first thing that you need to understand. So Rakesh Samanto, are you got cleared with this one, this concept?
Yes, sir. Actually, my another question is how the set the tolerance value for every aspect. How can I set the?
You don't need to set the tolerances. These are the values that will be that can be provided on the basis of how much parameters you have and what are the internal values of the parameter. You don't need to set anything. It will be the multi-collinearity analysis will itself provide you the values. And if you want to adjust, tell.
Okay, sir. Actually.
Okay, you don't need to set values. This will be provided by these are the statistical result. Okay, you provide the data, they will provide you the result. Okay.
Okay, so the next question by Pritam is what will be the good value for AUC accuracy?
Okay. What is the good value for AUC accuracy? See, a good value of an AUC accuracy can't be generalized in that way, but a value more than 0.96, 0.97 is a very much overfitted model, because then it will look like a 99% right model, but these are not actually in reality, they actually suck. Okay. So in reality, it is not that much good. So a good value is 0.85 to 0.95 is a very good realistic value, because the model will be not overfitted and the model will also not be underfitted, and you can match the entire results of that AUC ROC values with the ground values also. Okay. Pritam, got it? You got it? Okay, so what is the next question?
So the next question by Iqbal is, sir, how could you measure the tolerance and VIA? Also now the trend GEO-AI. What is the difference? GEO-AI while they also use GIS parameter data too.
See, GEO-AI is the meaning of GEO-AI is connecting the GIS that used to do in the past. See, You are using GIS parameter because GIS parameter are the data, and you are using AI to access that data. Before, we don't used to use the AI to access that data, number one. And number two is that GEO-AI means, GEO-AI means actually that you are connecting the geospatial data with the artificial intelligence to get an output. The output might be a classification, might be a forecasting, or might be a data-driven decision-making system that you can later integrate in a policy-making systems. Okay, or policy-making pipelines. Now the question is that how you could measure the tolerance and VIF. We can measure the tolerance and VIF based on the number of parameters we have. Suppose we have 10 or 20 parameters. We first normalize each and every parameter because each and every parameter needed to be normalized or scaled using standard scaler. After standard scaling, we will check the relationship between each and every parameter. I will show you one photo also, how these things, how these multi-collinearity checks are done, what are these multi-collinearity heat maps and everything like that. Okay, so I will take you side by side when I will go to the detailed part of the webinar. Okay, so what is the next question?
Yes, the next question by VK is how to validate the model accuracy with ground truth dataset.
I will show you one. There is a one way we have invented this one. This is a binary AUC ROC card. I will show you how we can actually calculate the binary AUC ROC with the ground validation. I will tell you that at the end.
Okay. So the same question by VK is how to create the mask TIFF. Suggest any way to automatically extract the marks TIFF.
How to
create the marks TIFF.
TIFF? Suggested any
way to automatically extract the marks TIFF. Yeah.
See, after you create a marks TIFF in the segment anything model, you can just convert it into the shapefile. And if your question is that how to create a marks TIFF over the building, see, when we are using a segment anything model, this segment anything model is a pre-trained model. Pre-trained model means this model has been trained over more than 1 million of building data set. So using a pre-trained model is very easy. You just use that model, assign it over on the satellite leaf map. It will automatically detect all the buildings. And it will create a TIFF file, and after that you have to convert that TIFF file into a vector shapefile. Okay. Then
okay, so the next question by Spandan Datta is, sir, can you please repeat the neural network architecture?
See, there are a lot of neural network architecture. Each neural network architecture is a different. For example, ML multi-layer perceptual neural network has a different architecture. XGBoost, I've explained, that has a different architecture, and density neural network has a different architecture. There are a lot more like CNN, SVM, more than looking at the neural network architecture. You need to understand that what are this architecture, why this architecture has been built in this way, and what are the output of this architecture. That means a CNN can't be used in a statistical analysis or statistical prediction, because CNN is, that is convolutional neural network, is based on the photo related. That is like in segment anything model, you can easily use, instead of segment anything model, you can use a CNN to see the building, because they can identify, their picture recognition is much better than the other architecture. Okay, so before focusing that much on the neural network, first try to understand what are the basics of this neural network architecture. I will show you some of the architecture later also as we go to the higher stages of the work. I will show you that, and how we create our own customized architecture. That will, and also I will show you. Okay, no need to worry. Achha.
Okay.
Then
next question by VK is how to decide the hidden layer of neural network.
Okay, this is a very beautiful question. That how to decide the hidden layer for any other whether you want to keep a 3-4 hidden layer or number of neural depth of 50 to 60. You can do it 3 ways. Either provide the default one as if you are a beginner, and if you are a pro and you have some complex data set. See, these are not easy to explain. These are some of the things that are needed to understand through the experiences. Suppose I have a very imbalanced data set. For that imbalanced data set, if I try to run a very complex MLPNN architecture, then the model will not run. Then I have to go on a simple default way. But if you have a huge amount of data, and each and every data, there are some good amount of well-biased sampling in it, then you need to have some deep hyper. This is the part that you told, the question that you told, that how we can decide the hidden layer. There is a special terminology to this, that is hyperparameter optimization. That how to decide it is not only the hidden layer of NN, but number of neural depth, number of output values, number of input values. These are known as hyperparameter optimization. Okay, just remember this term. And we can decide this hyperparameter optimization by tuning it. Suppose we got one result, and I found that the result AUC also is not good. Then I have to again tune it. I have to increase the neural depth. I have to decrease the neural depth. This is not a one-time run. You have to run it 2 to 3 times, 4 times, 5 times, 6 times, 7 times. In one of my paper, I have run more than 21 times to get a good result. Okay, and now there are some other plugins also in the Python. Other packages are also found in the Python, like Grid Search CV is there. Okay, Grid Search CV is a very good method to tune the hyperparameter optimization, because they will run this entire neural network into 4 to 5 stages, like with a neural depth 100, with neural depth 200, 300, 400, 500. Then they will run out number of NN. You have asked about the number of the hidden layer. They will run the hidden layer 3, 4, 5, 6, 7, and after that they will do a permutation and computation among themselves, and they will give the best output, like NN should be the neural depth should be around 60, number of neural network layers will be around 5, and this will depend what we do. Okay, and I think you got this is clear, and until unless you work on it, you will not able to understand fully, but this is the way. Okay, thanks for asking this question. This is a very important question, by the way.
Okay, so the next question by Shayam Shamanto is, can you please explain F1 score precision and recall?
I will just give me a few more slides to go. I will give you with explanation as well as diagram that how this precision F1 recall is actually occurring. This is also a very good question. Okay.
Okay, so the last question is from Akash Neil. Is the SAM exclusively used for detecting buildings? Can it also be used for detecting large trees?
See, segment anything model you can detect using large trees, but for that, I just want to tell you one thing. If you want to detect a very specific tree, for example, pine trees, there is a very visible example in an RGS for how to detect a pine trees. These trees are actually different from the other trees, because whatever species of tree that you want to detect, each and every tree shows a special characteristics. Okay, so in that way, you can identify each and every trees among the other trees. And if you want only to detect the entire tree species, then I will suggest don't go for this machine learning and deep learning. Take any good remote sensing satellite image and use NDVI. NDVI value ranging above 0.3 to 1 can give you a very good vegetation. Okay, you can use that. But if you want to detect a specific trees, then do one thing: download a high resolution images of that tree, and then train the entire model, like CNN model or RCNN model or YOLO V9. YOLO V9 is a very good model for image recognition. YOLO V9 model using the sample trees, and then project it over the large surface, you can detect the individual trees. Okay, these are the ways. So I think, Akash, you got your point, and if you have any other question, you can still ask.
Okay, so there are no more questions. One request from Rajat Kumar is that, sir, as per your experience, give some resources to learn deep learning.
Okay, just tell me one more.
His request is, sir, as per your experience, give some resources to learn deep learning.
Learn deep learning. See, the thing is that I'm very much sorry to say in this way, but there are thousands of books there in deep learning, but you will not able to understand the deep learning from the geospatial perspective, because there is not a single book is there on geospatial analysis by deep learning. But there are few books, like one book can be found in Amazon by Question Who only. He has written his book on GEO-AI. You can read that book and you can use it. See, whatever I have learned in last 3 or 4 years of PhD, in my entire research, I have not bought any book or anything. I have just learned it from internet, from GitHubs, and from the AI, from ChatGPT, and everything from there. Because there is no ready-made thing that you can find in this field, because this field is a very new field, and this field is still exploring a lot. So everyone is confused of what is going on here, how they will work on it, and what they will work on it, and everything like that. So thing is that you have to learn it from bit by bit from different things. It is a research. You can't learn everything from one book. So there are few books you can find that you can find some deep learning books, but that deep learning will be for business models. You can't relate that business model analysis with the GIS. Okay, this is the main problem. You have to explore this one on your own. We are all exploring this. So I have not studied any book on this, and there is no book available actually properly in this way. You can find a lot of book chapters and research book chapters online, but these are all, you can study that also, but I don't think that will be that much fruitful. Okay, this is the thing. But you can read some research papers of us, because reading a research paper can provide you an insight what to do. Okay, then what to do, why this VIF is important, why these tolerance is important, why these things are needed to be done. Okay, these things are there. You can read research paper instead of. I can provide you some good research paper of ours that you can read and study. These are some of the good sources that you can use in GEO. Okay, I hope I know that I couldn't solve your entire problem, but this is the very basic thing that we can do at present, because no proper book is there.
Okay, sir. Thank you. No more questions till now.
Okay, so we can again move to our presentation. Okay, so the screen is visible.
Yes, sir.
Okay, so whatever work I have done is, this is the scientific nature, scientific reports paper that I recently, that has been accepted few months before. It has not yet published, but it has been accepted. You can see this is our paper and how these papers have been made. A novel deep learning based spatial ensemble approach and segment anything model for landslide risk assessment in Chamlodishad of Karbal Himalayas. This was the paper that we have worked on this week. Okay. So coming to the next paper, this is our another paper, and I will tell you how we have worked on the Rad Bangla region of West Bengal. Now people from Bengal can relate this one. Okay. So we have also introduced a deep ensemble model to predict the drought. And this was the first paper of its kind that have, in a very detailed manner, in a very correct manner, has detected the detailed drought predictions of the regions of the Rad Bengal. Because before that, this entire study area with machine learning and deep learning, this type of work has not been done. Okay.
Okay. Sorry to interrupt, but I think your slides are not moving. So
Slides are not moving?
Yeah. So can you just turn it to full screen mode? I think.
Oh, sorry. Is it okay now? Is it okay? Is it
No,
moving?
it is actually not moving. I mean,
Okay, just wait for 1 minute. Let me see what's happening here. Uh, Let me see. Uh, why it is not moving actually? I am stopping my presentation and again starting the presentation. Now it is okay? Hello?
yeah, your
Now it is
screen is
okay?
visible. Yeah.
Huh?
Yes, your screen is visible.
Now it is visible?
Yeah, now it's visible.
So this is the last paper that I was talking about, the scientific reports paper. Okay, the page is visible, scientific reports. Hello? Is this page visible?
Yes, sir. Yes,
Yes.
sir, it's visible.
Okay. So this is another paper, next one. Can you see the paper? The innovative ensemble approach of deep learning models in soft computing. This one?
Yes, sir.
Okay. This is our another paper that we are working on the Rad Bengal region. Okay. This paper has got into some good Q1 journal known as ESPR, Environmental Science and Pollution Research. And okay, let's move directly to the paper what we have done. This is the study area of Rad Bengal. So majority people, I think, are from the West Bengal, and you can see these are the Rad Bengal region that we have worked on it. Okay, so you can see the elevation height, and you can see the detailed study area, and you can relate with this. Okay, so these are the parameters that we have taken in the same way. Okay, but the things are different from here. See, after creating this parameter, we have created this detailed maps of each and every one. We all know that how to create this type of maps in GIS and remote sensing. Okay, but this is some of the laborious work done by one of my colleagues. He is the first author of this paper because this is his PhD work. I have worked with the algorithm development actually. So he has made this GIS-based maps actually, and then after that, but see, this is the entire methodology. This is the drought inventory. We have to first identify the inventory. That means based on the past location or past literature, to find where the drought are occurring. Then we have to connect these targets or this where these droughts are occurring with the number of variables. Okay, so we are connecting when this dots with the number of variables, what is happening? Then we are doing a collinearity assessment like multi-collinearity test, and then we are applying these neural network algorithms so that we can get a detailed map. So what are the detailed map? You can see this is the neural network architecture that I have made, and you can also make this type of architecture in a software known as Netron. Okay, I just want to show you this one. See, my screen is visible or not? Just tell me. Is it visible?
Yes, sir.
Okay. So then suppose for example, I'm going to Google Chrome and I am opening it and I'm going to Google and okay. So the Google is visible now. So okay, here we can write Netron. Netron. Okay. Netron. So this is the particular website. Okay. Here we can put here I can click on it and here I can add all the values. Okay, this one has the Netron. We can open the model and we can put whatever the Python code that we can here, and we can put it in this open and we can click it here, and we can get a very good output of this model. For example, let me see on hands-on actually. Let me see whether I have anything in this on this file or not. If I have, I will show you. Okay. Okay, see, this one is an Ansible model code. Okay, I'm just clicking on it and I'm just opening it. They have made me like that. This is just the code. I have just provided in what I have given the in input sequential. I have provided it and it has created me a beautiful architecture map of it. Okay, how many loops I have used? 20. How many configuration layer I have used? That is 1. I have been squeezed it, I have used in value, that is activation function, and then I have used sigmoid function. Each and every of these functions can be shown here. See, this is the power of an GEO-AI. Okay. Are you able to see this? Can you able to see this? This one? Are you able to see this?
Yes, sir.
Okay.
Yes, sir.
How easily, with the help of the code that you have created earlier, you can convert it in an ONX file, and then you can easily see. You have to understand these things. That I have to make a very complex, good neural architecture that is a publication standard. You can use this type of ONX files. ONX files means whatever Python code you have written, convert it in an ONX file, and you can put it here. You can get a very good this type of image. Now you can take a screenshot of it, you can download it, anything like that. Okay, you can export it as PNG or SVG, anything like that. You can use it. See how simple is it? Okay, so let's go to another this one. Okay, let's go for another time. Okay, to give you more understanding. Okay, wait for me. Not into the GitHub. I will also show you the GitHub, also my GitHub actually. So we have first use ensemble, then we can use MLP regression. You click on it and you open it. This is a simple MLP and regression. We have provided an input file. There are this number of value, and this is the output. The activation function is value. You have to understand this thing, what is this value, what is the sigmoid function. You have to study for that because this is not easy to study in one day. And these are number of batch normalization, how many batches that I have used, how many 64 neural depths are there, and the final output is only 1. Okay, so either it is 0 or 1. The next one is 32. So in this way, you can see how we can create a very simple algorithm out of it. So see, we are currently working on this, so these things are very much easy for us, but to understand for the first time, you have to put me 3 to 4 days to first understand how this Netron actually works. I just show you in just a span of 30 seconds out of it. Okay, so these are some of the things that you need to learn, but that's more than enough. Okay? So after that, I will show you my GitHub actually. So I'm just keeping it open. So later I will show you how this entire GitHub actually occurs. So this is my GitHub profile. Okay, so I'm just minimizing it. Okay, let's come to our script. Okay, so you can see how these architectures can be easily made using a Netron app. You can easily make that. Okay. So now this is the entire full stack architecture methodology that we have created. Okay, how this entire function work, how this entire all of these architectures have been created using. This is the complexity of our model that got published recently on the deep ensemble learning, and after that we can show you how each and every. These are the Netron, again the Netron app. This is how the architectures have been created, and these are the AUC ROC curve. You can see the AUC ROC curve values. Okay, so how these values are increasing and decreasing for each. These are 3 AUC ROC values together in one year. 3 months, 6 months, and 12 months. So if you're working on a drought, you need to calculate for the 3 months, 6 months, and 12 months. 12 months. If exercise is something like that. Okay, standard precipitation index. We need to calculate that for 3 months, 6 months, and 9 months or 12 months. Okay, so now coming to the most important thing, that is the this is known as the confusion matrix. Okay, so now you will want to understand what this confusion matrix is, how to understand this confusion matrix. The confusion matrix, you can see there are 4 columns. Understand from this first image. Okay, this is an MLP. Okay, this is multi-layer perceptron 3 months where F1 score is 0.848. It's a very good F1 score. Okay, F1 score means the ratio of precision and recall. Okay, so you have to understand these 4 quadrants. This is 0 and this is 0. So 0, 0, this is 1, this is 0, this is 0, this is 1. And this is 1, this is 1. So basically the thing is that these are known as true negative, true positive. Okay, you have to understand in this way. False positive and false negative. Basically what is happening that we need to work on this one and this one. This one means, for example, these are the points or the places where there is no drought, number 1, in the inventory, and our result has also shown that this area has no drought. That means this is true negative. Okay, the occurrence is 0, the in inventory it was also 0, and in final map it is also 0. So that means the value is correct, this one. And then this one means, that is 181580. This means these are the point of occurrences where inventory, that is the target on the basis of which we are working on this machine learning model, shows that the values of this one is actually drought, and in prediction also we got this a drought. Got it? You understand this part? Tell me this one. Otherwise I will again explain it. Please tell me.
Yeah, get it.
You got it?
Yeah.
Okay. And so now coming to this quadrant, this means that these are the number of samples, 42,000 among total samples. These are the 42,000 samples, which is actually not a drought region, but model has by mistakenly calculated this one as a drought. So this is known as false positive. Okay, this is true positive, this is true negative, this is false positive, and this one is false negative. That means this 22,446 parameter were actually a drought predicted region, but machine learning couldn't identify them as a drought and they pushed it into a non-drought region. This is known as the confusion matrix. I hope you got the entire scenario, because you will not get this entire scenario by observing the AUC ROC curve, that is this one. Okay, but if you see this confusion matrix here, you can understand that actually among this entire work, total here in the total number of drought or point of occurrences of the inventory, we have successfully calculated that around 181560 has been calculated as the true drought, that is correct, and around 161025 has been calculated as a false region, that is a true non-drought region, that is also correct. So only few are there that has been in a not properly detected, and that's why our MLP and F1 score has not gone to 0.1, it has come down to 0.84, and 0.84 is a very good realistic result. Okay, I hope now all of you have got some idea about what is this accuracy assessment. This is very much important in AI and machine learning. Okay, have you got it correct? Okay, have you understood? Anyone facing any problem, you can please tell. Okay.
So the upper right corner is actually depicting the type 1 error.
Yes, that is a type 1 error. Okay, you have, okay, I got you. People got connected with type 1 error. Yes, this is the one, this is the sophistication part of type 1 error. Okay, so you can relate with that also. But in very basic way that I have to told is that it is the main phase of this 4 situation is known as true positive, true negative, false positive, and false negative. Okay, you can use that in type 1 error also. That is we also say. Okay. There are type 0 error and type 1 error. Okay, can we move? So should I move to the next slide? Because a lot of people have confusion with this confusion matrix. So the name suggests that yes, it has a value to its name actually. All people got confusion matrix. Okay, so after this confusion matrix, we got a very detailed map of the region where the areas have been very high with this drought area. You can see these regions have been very high into the drought area actually, the Rad Bengal region. Okay, so this was our findings actually, and this is the another drought prone region that it is made up of MLP model. This is made up of DenseNet model. Okay, and this is the map of showing that which particular districts have very high and very low. We have made a classification out of it. All this thing had been made in a Python. This entire model has been created in a Python, and it has been put because this type of maps we can't make in properly that much in Excel file also. We have made it in Python. Okay. So another important thing that I want to show you is another paper on this region, the architecture, that is this one. Okay, this is a shape diagram. Okay, along with the confusion matrix, we are also providing a shape diagram, which is Shapley diagram. Okay, so what does the shape diagram show? Okay, I just want to tell you one very interesting thing. The shape diagram shows that when you are running a model, which parameter is the most prominent ones, most important feature while executing this entire MLP process can be shown in the shape diagram. Okay. So through this shape diagram, we got a very important information of this one. Okay, you can see that in the Rad region, you can find the red regions. Okay, now listen this observation from. See, running a machine learning model is not always important. Actually, it is important. What is important that I will show you. When you are running this type of machine learning models, you are getting a good result. You can see that very high region of the Rad region. This is the mountainous region, the Chotanagpur region. Like Purulia, Bankura, Jhargram region, some part of the Jhargram regions out there. So majority of the paper in West Bengal has told that this region does not receive that much rainfall. That's why this region has been brought. And we all know that the Rad Bangla region doesn't have that much rainfall. Always these regions have been devoid of water, or always these regions have been devoid of food. There is a drought and famine occurring in this region. This is the most drought vulnerable regions of West Bengal. But do you know what is the main reason that we came out from our research? It is not the rainfall, it is not the water. Okay, it is the soil characteristic. The soil is very much hard, and it is not the rock structure. The soil structure is the most important culprit for this economically as well as environmentally distressed portion, because the crops cannot be grown on this type of hard rocks. Water is there, water is flowing away. Okay, but the soil is unfit for cultivation. So if there is no cultivation, then there is a very shortage of food in this region, and rainfall occurring is okay. The rainfall is good. A lot of Bengal region is receiving very good rainfall. This region is getting very good rainfall. So you can question me that why you are telling me this region can get a very good rainfall, is having a very good rainfall, because when we are using the IMD data to calibrate this standard precipitation index SPI, we found that rainfall is quite high in this region. Okay, so what is the problem? Then after studying few papers, we found only one paper from the Water Resource Engineering department from Jadavpur University professor. He only told that the main reason for this entire drought of this region is only because of the, is mainly only not, it is mainly because of the soil and the rock structure. It is not, and not the rainfall is not the sole responsible. It is not the most important responsible parameter. Okay, but rest all the paper has shown it is the rainfall, because it is quite common in our mouth that Purulia, Bankura receive low rainfall, so they are researching and validating. So this is the importance of a machine learning model, because when we are using shape diagram, we found that in the shape diagram also the geology, soil, geomorphology we have taken are coming in the top in the shape model. So you can see we are not only predicting the drought, along with the prediction of drought, we are also predicting which parameters among the all the parameters that we have taken to assess the drought, which are the most important. And we got a very good validation with the Jadavpur University's professor from the Water Resource Engineering department. So see how this is not only predicting or providing a map, but also providing us a data-driven decision-making policy pipeline framework. See, Today, I can go to government of West Bengal and tell them. I know they will not listen to it, but I can tell them that this is not because of the water; it is because of the soil geology. This is the thing, and we have some backed up with some data-driven decision-making policies. We have backed up with the data and proofs, and this is the paper. Okay, so in this way, in outside in countries like developed countries, they use these academics have been given a very good position in hierarchy. In India, unfortunately, academics are not the most important aspect in the society. They will tell you the पढ़ने वाले बच्चे हैं हमेशा पढ़ते रहेगा. For them, getting a good government job, getting a good administrative job is much more important. So this is the thing. So academics has no role in Indian development that much. Yes, true, it has played a very important role before. Now it is of place. Okay, so but yes, help.
Sir, I just asked you that what are the difference between your three maps, 3 month, 6 month, and 12 month?
What are
the difference in your three map, like 3 months, 6 month, and 12 months?
Okay, you can find there are differences. You can see that in this region, in the map D, 3 month, you can find this region that this region has a very high growth. 3 months means a short duration scarcity. 6 month, 6 month means a more duration a high duration scarcity. See, you can see the map is changing here. To understand this map is very crucial here, where these occurrences are changing. And in a 12-month, you can see that in a 1 year drought prediction, you can see the scenario is again changing. You can see in a 3 month short duration, you can find a very high in the eastern part of the map, but in a 12-month, that is not present. Okay, so see, this 3 month, 6 month, and 12-month is the standard precipitation index calculation. Based on that, we are making the drought maps. So in 3 month short duration map, 6 month long duration map, and 12-month is a long-term map. You will find some basic differences. You will not find a very huge differences, but you will find some basic differences. Okay, these are the standard way of researching the drought regions. Okay, I think I am able to solve your problem or solve your question. Sorry,
Sir, if you overlap your NDVI, then NDVI value should low in the highly prone area, very high prone area.
NDVI.
Yes, NDVI.
No, it is not always, because in this part of the region, okay, we have a high NDVI one. Okay, but still this year very less than 2024, very less rainfall occurred in this year in this region. Okay, that's why the IMD data has provided that this area there is not as much high rainfall is present. So that is also a point. So you can't actually decide anything with the basis of one element. You have to take all the parameters to understand the entire scenario. You got it?
Yes, thank you.
Okay. So in this paper, I have shown you that how this shape diagram is actually working on. And see, these are our field verification. We have gone to the field and we have got some very good information after creating this map. We visited each and every field. So see, until and unless you are creating this maps, or until and unless you are creating this entire prediction map for forecasting, you can't go to field. So after creating this map, we visited the field and then we have assessed each and every locations where this things have occurred, but this is not occurred actually. Okay, it will give you a clear picture on it. Okay, now coming to some of the more important, interesting projects that I have done on. Okay, so this is so it might be looking much more monotonous that we are talking only on papers. Let's come to the work on some real life. Okay, suppose you are doing some sampling. You need some random sampling from different places. So here I have used this random sampling technique. You can see that this is a study area of Chennai. Okay, so in this study area of Chennai, I want to show you how a unsupervised machine learning model can help you to collect a huge number of random samples. So you can see that this is a k-means clustering method. K-means clustering is a part of an unsupervised machine learning model. Okay, so here you can see the number of zeros are there and number of one are there. So among the number of zeros for a machine learning to work it, maintain the grammar of a machine learning, we need all the point of occurrence and point of non-occurrences to be equal. Though we always don't keep that equal, but if we need to keep it equal, we need to do some sampling. That means the number of zeros here are in blue color. So number of zeros are less, and the ones are in red color, and ones are very high. But I need somehow that I need equal number of one from all the regions. That is evenly spread from each and every region. That means suppose there are 1,000 zeros. So among 10,000 ones, I want only 1,001, but I want all 1,001 from the equally spatially distributed region. So how we can use these random sampling techniques to extract that one value from all the coins, and in such a way that this one will not be lying in, not be clustering in one from one region. So we will not get all the values. So what happened? We have had a k-means clustering, and in this k-means clustering, I have made 20 different clusters. Okay, see here are with 0 to 19, that means 20 different clusters. So we have to first define how much k-means cluster we need. So I define 20. So what happened? So after taking the 20 different clusters, what happened? We have then, see, you can see the cluster is here, one cluster is here, one cluster is here. Among this cluster, okay, among the cluster, we want to take 70% of the data or all the data, whatever we want. Okay, we want to take some of the data from this. So we write over that I want this amount of data from this cluster, so that my total samples can be collected to provide a very good value. For example, I have made a big cluster. From big cluster, we need a big proportion of data to make up equal proportional samples. Okay, so see, random selection is also not easy. You have to use some methodologies and techniques so that you can get an entire random sampling from your entire area. So this is one of my mini project based work. So I have made this one. Okay, I don't know whether this, okay, this one. So I have this. If you want this algorithm also, it is already there in my GitHub account. I just want to show you. This is my GitHub account, and here I just want to show you data. This one, I think it's this one. You can go and observe this one, the geospatial data handling. Here you can learn all those images, all those everything, sampling, data balancing is there. You can, from here, you can download the code. You can download this zip and you can use the code. The code is there. This one is the code. Sampling, data balancing, IQ by NP. This is the code. You can use that code and do it in your own study area also. So you can download this code from my GitHub account. Okay, it is free and it is openly available. Okay, you can use this. So these are some of the things that we have made. Acha, my screen is visible or not? First tell me this.
Yes, sir.
Yes, okay. So I know that this not sounds a geography a bit, but this entire work is on geography. So next time, whenever people ask you, what is this role of machine learning in geography? We were good at with our own work, tell them these experiences. Okay. Because you are the youth and you are the next torch bearers, and I want all you to use this AI in each and every case. See, it's not only a physical based work. So, for example, you want to visit some of the villages, and you want to randomly select the villages where you want to visit. Because one of my friends, she was the topper of President's University, and she was working on this Kurtoli village in the Sundarban region, and she just once asked me about. She wants to visit and she wants to meet to 14 to 15 randomly sample villages. So how she will do it? So I told her this is the way, and I made her an entire outline of it, and she visited and it just benefited her a lot. She got a promotion for showing this entire science backed or ML backed methodology in their real field actually. So see, you can use this type of things in your human geographical aspects also if you're going for a surveys, because we have also done surveys. We are using machine learning, we are doing surveys, we are doing each and everything out of it. So you can use it. These are very much scientifically backed. Whatever you do, it should be a science backed, and you can use AI machine learning, then it will be a cherry on a cake. Okay. So I hope you understood this context, because see, each and every slide that I will be showing you is of different dimensions. Okay. So just tell me, you understood this one or not?
Yes, sir. I have a question actually.
Yes.
So, how many ground truth points are enough for a district like Chamoli? Or for, let's say, if we want to map the entire state of Uttarakhand for validation, how many ground truth points should we collect?
Okay, so you want the ground truth for email validation or for a survey or a quantitative survey purpose? First, tell me that one.
For validation.
For validation of a map.
For let's say
Hmm.
you have created a landslide susceptibility map.
Hmm.
So for that, how many should we create for validation?
We
Should
have
we
taken
collect for
around
validation?
400. We have taken around 400 actually. 410 or 415. And
Okay, okay, so
that is ground validation. All you cannot be taken from by visiting the field because there are some inhospitable regions also. So by visiting the field, I have collected around 239 or 245 points, and rest 135 points I have taken from the Google Earth images.
okay,
Okay.
so one more thing.
Hmm.
For let's say you have created the landslide prone mapping, and
Hmm.
there are certain places that you physically went there and you collected. Okay, this is aligning with my map. So how
Hmm.
did you come to know that this place was actually landslide prone? Was it due to some past landslide accidents there, or
Yes,
how
it is.
did you come? Okay, okay, okay.
I got it. The targets that you are talking about, then from where we are getting the inventories, we get these inventories from various sources. Like when there is a region which receives past landslide has always a chance of getting landslide again. Landslides are recurring. Okay, landslide is a recurring cheese, recurring object. Because if you go to the Patalganga landslides of the Himalayas, which Chamuna district my supervisor tells, lack of scientist profession is actually based on the recurring landslides of the Patal Ganga. So see, it is recurring. So past landslide always provides you the best thing because it is always in academics. You will always find that whatever data and information you get from the past, it helps us to shape the future. So in that way, it is always that past landslides are the most important thing that we, because until and unless past landslide is connected with the physical parameters of the region, we cannot tell that whether this area has a high probable chance or not. Okay.
Okay, so thank you.
This is, for example, I just want to tell you one example. Suppose a region which is a very high slope. Okay. And that region has not received a single landslide. And that region also has a very active fault. But realistically, that region has not been identified as landslide before because no landslide has occurred there. But suppose for this Patalganga landslide in my study area, if I see and if I find that there is a past landslide on this active fault, then the model will try to understand that when there is a fault line, there is a very high chance of predicting if the landslide can occur. So in a new area where there is an active fault below and still no landslide has occurred, it will always show that this place is always susceptible or always probable that this place has a high occurrences of the landslide. Okay.
Okay, sir. Okay, thank you.
This way we are predicting. Okay, so we need a diverse scenarios and diverse case scenarios to build a predictive model. Okay.
Sir, hello.
Huh.
Sir, basically, I am working with the real-time data. Okay. So the landslide is basically triggering by the rainfall mainly.
Huh.
So I have the real-time data of rainfall of each stations. Okay.
Rainfall of each
Stations like if, for a district,
you
they
have a
have.
which area? You have a which area?
I am in Maharashtra area. Okay.
Okay.
So entire the Maharashtra, I have 3,000 rainfalls. Sorry, 3,000 weather stations, and they provide me the live rainfall data. So how I said that if this much rainfall is happen, then this area is probable for the landslide.
Okay, I got it. Acha, yeah, this is a very interesting question. So, actually, in Maharashtra, which region you are working on landslide? Just tell me. Because I have some experiences there also.
Basically, in Maharashtra, Raigad and Ratnagiri, these are the landslide prone area.
I have actually worked on Satara district actually. Satara district landslide.
Satara also.
Okay, I know. So I am telling you things. Okay, and now this is a very interesting question that I have got. Thing is that you first need to understand two things. That the Himalayan landslide system is different from the landslide system of South India. Okay, because in Himalaya there is a very active fault is also playing an important role. And for your type of work that you are working on it, okay, you have got some data. First, assess the weather. First, tell me one thing, that whether it is always the rainfall that is leading to the landslide in your area. First, tell me that.
Sir, 90% is triggering by the rainfall and 10% by the human activities.
Acha, 10% is
By the construction or any.
see, it is that you can't tell 10% by the construction and 90% of rainfall. You can say it is a blend of this rainfall and construction that has leaded to the landslide. Because last 30-40 years before also, there was no that much huge landslide is occurring in that region. Okay, so now what is it occurring? Because it is the Anthropocene effects along with blended with the rainfall actually. So I just want to tell you that to work on this, you need to first calculate the rainfall threshold. Okay, that this is a very tedious work. A lot of IIT Roorkee's CBRA department people are working on it. One of the senior professor, Professor Devi Prashanna Kanungo, is working on it. He used to create what happened. He used to create one entire physical mechanism and used to trigger a natural rainfall. Okay, there's an artificial ecosystem and creates a artificial rainfall and see at what intensity and at what saturation level and at what point the slopes start to get failed. So they started to calculate the initial slope failure along with the intensity, duration, and of rainfall as well as saturation of that soil to get these rainfall threshold. You can in your area, if you are working on any project, okay, you can ask them to make this one, or you can refer some of the paper, okay, to understand there's what type of how much rainfall is actually needed, because it is not only rainfall, and rainfall along with slope, along with what type of soil geometry is there. These things are also important. Okay, so this part is the beyond the scope of susceptible maps, but this part is a part of a geotechnical field actually. If you are looking for a geotechnical phase of a landslide, you can use the rainfall threshold. There is one very good senior of mine is working in IIT Delhi now. He has also made a numerical modeling on this rainfall, and he has introduced his own way of rainfall threshold actually. Okay, so you can read his paper also. His name is Shubham Das. You can read his. The paper has been accepted in Natural Hazards, I think. Okay, so you can follow that, because Himalayan scenario and the Maharashtrian scenarios are not actually same. Okay, so I was working with the TIS, with the Department of Disaster Management to work on it. So, okay, so I have few experiences, and I've seen that it is not the precipitation, not always the precipitation, but precipitation along with the Anthropocene and some of the geotechnical aspects that are needed to be maintained. Okay, got it?
Thank you, sir.
Any other question?
Sir, good morning, sir.
Yes.
Sir, actually, the GEO-AI models which are there here in your explanation, can we use them, or we can reflect the same for the land subsidence also, sir?
See, the algorithm is same, but you have to tweak it, because for land subsidence, you need the DEM differentiation methodology and you need the SAR data. Okay, so you have to first use the SAR data, calibrate it, and then do the DEM differentiation, and then you can use the algorithm to detect. Because detecting land subsidence, because you'll first have to identify where these land subsidences are occurring, and gathering a huge amount of data of land subsidence is not possible, but you can do using a traditional method also. You don't need GEO-AI for this land subsidence, but you can.
But the thing is that, sir, actually, I have done my MTech thesis from the Krishna Godavari basin of that area, sir, in Andhra Pradesh. Actually, I have used that persistent scattering meter technique for that. And actually took the soil of the particular, and I have the lab test also for that. And I have done my thesis and I have submitted it. But I am very much interested in this particular point because I have done a lot of work to get those all, like to have the particular points where it will subside and where it will rise. We need to take and we need to do this all. But when we come this algorithm and GEO-AI, if we can make this two of this, is there any like, the probability of getting result will be different or same?
Okay, I got your point. The thing is that you told that the work, your hard work you have to do to this entire thing, you can replicate it using transfer learning mechanism of ML model. Okay. I will suggest you not to go in this algorithm because these are some basic algorithms. You have done some good work. So go for some transfer learning. I am also working on some transfer learning in debris flow modeling that is similar to like your land subsidence. So go for transfer learning and build some algorithm on the basis of that. Okay. I think it will be much better to work on that because it will help you to remove the tediousness of your work. And secondly, it will be a very good innovation. Okay, go for transform learning of ML model. It's so
Sir,
uh,
if we use the same, shall we can get that same like values and the things which we are doing on the land and the Himalayan parts and everything, where
no,
we will see get
you
the
will
same
not
or
get the same. For Himalayas, the results will be different because Himalayas triggering factors and subsidences are of different type than of in your area.
Sorry, sorry if I'm not interrupting you in this wrong. If we have the information regarding the past 3 years or 2 years back, there is a landslide event which has happened in the Joshimath because of land subsidence. I think you are got into that information, right, sir?
Yes, I am working on it actually. Till
Yeah. Very good to hear, sir. Actually, so in the same, if we have that algorithm to the KZ basin of the particular Krishna Godavari basin, shall we can train the algorithm to use the same in Joshimath also, sir? If it cannot, sir, actually.
See, if you want to try that, now first thing is that I just want to point out two things. There is a huge debate on this thing that whether it is a land subsidence or a debris flow because the entire Yoshimoto is standing on a debris actually. So the European researchers consider it as a slow landslides and Indian some of the people consider it as a land subsidence. So for me, what I found best is that because I have gone to that place and I visited the places where that to identify the crown of that landslide or the land subsidence where it has occurred, and I found that the best way to detect the assessment is using a debris flow modeling. So actually, I'm working on a debris flow modeling named Sinks flow, and I'm using the transfer learning to predict whether it will get triggered again, and from which point it can flow out and create a huge amount of disaster. So instead of landslides, I am actually looking onto it as a debris flow actually, because if I have to go for a postdoc, each and everyone will tell it's a debris flow, or it is not a it is a slow landslide actually. So I have to looking forward to that only because nowadays very new researchers are also telling it is a debris flow also. So I am working on debris flow part, not on the subsidence part. I thought before it was subsidence, but later I visited the place and I found it's a debris flow actually.
Okay, sir. Sir, thank you so much, sir. At the same way, what you told to make that tidiness project into the easy way, I will do that for that algorithm. And I have
Yeah.
noted the things which you have said. Thanks for your information. Sir.
Okay. Thank.
Thank
Shinjan, is there any question left, or shall I go to the next part?
Yeah.
Stanley.
So there is some questions in the chat box.
Okay. Please tell
So
me the question.
yeah, so while you are showing the drought map, there was some question by Pritam. Is map is created in GIS or Python based environment?
It is a mixture of GIS because whatever the results we are getting from the Python, and then we are converting it into a geospatial map.
Okay, so the next question from Pritam again is that how to convert Jupyter Notebook to ONNX to open in Netron?
Okay, you can just convert just. I just want to show you one file. I think if I have, you can do one thing is that you need to format an ONNX file. Just change the name actually that .ipyb to .onnx. It can be easily done. Okay.
Okay, so the last question is from Vicky to how to create the patches of image. For
How
example,
to create
21
the
patches of image like 128 into 128 of same size from satellite image.
okay. Oh, for that, I think I just need to show this one. Let me see whether I have done because I've done it in 2022 or 23. Okay. Let me show you. Okay. This one. My slide is visible. My page is visible. Huh?
Yes, it is visible.
Let me show you if I have that is in the back end or not. Let me see. See if I have. this one, I think. I don't know even. Yes, it was this one actually. See, I'm just closing it. This is the entire model. I am just okay. I just want to put it down. Now the screen is visible.
Yes, it's visible.
Okay.
Yes, sir.
This is a segment editing model that I have done on it. Okay. So I have done it in 2023. Okay. So if I forget anything, please forgive me. So this is the polygon that I have created on which area I wanted to do this patch normalization and the patches of the segment editing model. And this is the leaflet map actually. You can see I have just imported the leaflet map here into your basics of Python. I have used this ROI bound. This ROI bound is this one. Okay. ROI bound is this one actually. Okay. I have used that. And then I have downloaded the map tiles. Okay. I have given here, I have given this one and downloaded the map tiles. And then what happens is it shows you a patch by patch image. So first I have done with this small image, then I have done with the side of this small image, then I have done with this side of the small image, patch by patch, so that I can get a good data out of it. Okay. So after that, I have used that model SAMGeo, that is segment editing model. Okay. And this model has run. So you can see it has taken a lot of time. Okay. And around 168 Mbps is a technical speed, and it has created this particular if. Okay. Mask file. After that mask file, I have polygonized it over the that is the satellite images, and you can see all these mask files are there over it. Okay. After that, these are the satellite images. Okay. You can see this one is there. This one it is segmented and extracted. And after that, what happened? These are optional visualizing the result, and I have converted this one from this. This is the vector file to the shape file actually. Okay, I've converted this to the shape. I think you got it. Any problem here? I have made this bound based on the polygons actually. I have just made the bound using the drag and drop method. Is it okay? The person who is having a question regarding this.
Yes, I think it's okay. And there are some few requests for you. So anyone please share the collab link?
This is okay. Acha, you want to get the collab link? Okay, I will share with it. Okay, okay, okay. This is the collab link. Okay, so I'm just copying the link. I don't know whether you will be able to open. I'm just sending it here. Okay. So in the chat. Okay. So okay. I have sent it. You can practice it.
Yeah,
Okay.
I think it is also requires the access permission also.
Okay, if it provides, no, I think it will not. And I'm just telling one thing. You can visit this website also. It has already been there by quizzing. Just wait a minute. I'm just showing you. Okay.
So it's requiring access basically.
Okay, okay, wait for 1 minute. What happening? Just wait for 1 minute. It is showing access, na? Okay, okay, that's why I got a lot of information here in my phone. Okay, just wait for 1 minute. I'm just showing you one more thing. Oh, I wrong a very wrong spelling. Okay. See, you can use it from here also. Okay. You can use it from here also. These are segment editing models provided by them. Okay. And I have got the same models. I see this one for 1 minute. This one. You can take this one also. GEO-AI. I have seen one. I have learned it from one website here. Okay, so let me see which website it was. But Acha, how will I provide that link that can be open for them actually. If I
Yeah.
share it,
You can share it with anyone, I think.
okay, just tell me how to share it.
You
This
can, you
one, how
can,
to share this.
in the share option, in the left part, you are seeing one share option. In the left of your screen,
Huh? Late?
left side of your screen. Sorry,
Okay.
right side of your screen. Right side of your
In the right side.
Yeah, share.
Share. Acha. Okay, 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 okay. I got it. I got it. Sorry. Oh, it is restricted. It is anyone with the link. Okay. So I'm making it. I'm copying it and I am sending it to you. Okay. Sorry. 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 Let me paste it. Hmm. See now, is it open? Please, anyone open this one and tell me whether it is opening or not. Okay. Just tell me once. It is opening or not.
Yes, it is opening now.
Yes,
Okay.
sir. Opening.
Okay. Good. 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 Now you can follow that one and you can work on it. Okay. So I am actually closing this one. Okay. I'm closing this Google for that. Okay. So now this is the Python code I will show you later. Okay. So okay. Now let's move to this one. Actually. Okay. So it is not showing. It is showing. Okay. The next part is okay. So this is another beautiful work that I have done on the Chennai flood susceptibility modeling or the flood modeling using random forest method. See, these are the same things, same confusion metrics, same collinearity analysis, then feature importance graph that I have worked on it. You can see this one in this. I have this entire algorithm has been provided actually. If you want to see this one, I have an entire algorithm provided here, and this algorithm is here only. Okay, in my GitHub. Okay, so you can visit, just explore my GitHub, you will get a huge source actually. Okay, this is going to show you something out of here. So it will not make you a boring that I'm always giving lecture. I'm also showing you flood prediction. This one, flood prediction using random forest algorithm. This is based on the random forest algorithm. You can use it. You can download the code from here. You download the zip file because it also has this one. There's two detailed PDF is also provided with the code and everything is provided. Okay, so these are the places from where you can get the clone from here also. I have written everything here. It is entirely detailed what to do, how to do, and the PDF is also there. And if you want to see how PDF looks like, I can show you one, I think. Let me see whether it is this one or not. No, this one is a different. I will show this one also because you can find it in these GitHub also. You can see two PDFs are there. You can download that PDF also. And in my LinkedIn, I have provided this entire thing. You can follow me on LinkedIn. I will provide you the LinkedIn barcode in the after the end of the session. If you follow me on LinkedIn, I regularly post a lot of the work that I actually do. Okay. So this is a very beautiful work. You can actually follow. You can start with this one also. Okay. Any question regarding this flood? Anything? Any question or any doubt regarding GitHub and anything like that? If not, then I will go to the next slide and show you. Okay, so this is also one dimension of the work that we not only restricted to landslides, droughts, we have came to floods also. So okay, we have done the work on the floods here. And okay, now I will show you one hands-on actually. This is basically this is a hands-on training on how to deal with the data. See, whenever you will be working on this type of work on susceptibility, you will find a very big problem. A problem of what? A problem of data scarcity. Okay. So what type of data scarcities can be found? That is when you use multi-values to point in ArcGIS, when you use overlapping a lot of layers, there will be an edge effect. Edge effect means two layers will not properly be overlapped. Okay. So this one extension part will give an error of -999. Okay. So how to solve that error? I have used one software here to solve that error. I have developed this software by myself only. Okay. So you can use this software, you can download this software. I will show you from where to download it. It is also open source. I kept it open for everyone. Okay, so I just first want to show you what this software actually does. Suppose this is an ArcGIS code you are working on the point data and see On this part, there are minus 999 error. So I have one software named as this minus 999 GIS data cleaner that I created, and where you can directly upload the shapefile. Because in GIS, solving this is not possible. Okay, and if you want to solve it in Excel, you have to convert this entire file into Excel and to convert the lateral, and then you have to reproject it. So during this reprojecting back to the GIS shapefile, a lot of data gets distorted. So to remove that or to avoid that error, I have created this simple software through which you can directly input the GIS data and you can get a very good result out of it. So I just want to show you that the software is in my GitHub. I will show you everything hands-on now. Okay. So this is a software interface where I will provide the data and I will choose the output format. It is in .csv written, but let me change to .shapefile. And you can see a number of minus 999 counts are there. It will show you around 45, 42, 40, 105, 45, it will show them. And then after clicking on clean file, clean data, it will show that after cleaning, there is no missing values or no minus 999 values. And you can easily visualize that. Okay, so let's show you one of this hands-on training actually. Okay, first I will tell you from where to download this data. Okay, you can visit my GitHub and you can go to the repositories. Okay, go to my repositories actually. So in my repositories, you will find this one, minus 999 GIS data cleaner. Okay, go to that, click on it, and it's a simply plug and play software. Then you will be visiting here. You see here it is written that release 1, that is the version 1. This is the version 1.0. Okay, go to this version 1.0. It will lead to this page, and here you can download it from this one. This minus 999 GIS data cleaner 2.exe. Then exe file. You can download it from here. Around 1 GB data is there. You can download it from here and you will use the software. And I will tell you how the software is used. Okay. So first, I just want to minimize all those things actually. My page is visible? Huh? Tell me this one. My page is visible? Okay. I will open the ArcGIS then. I will open the ArcMap. Everyone is accustomed with this ArcMap? Tell me.
Yes.
Okay. So let the ArcMap.
Yes, sir.
Okay. Let the ArcMap be open. Okay. I will tell you what to do and how to do. But my page is visible or not? It is visible?
Yes, visible.
Okay. Okay. Suppose I'm looking for a data. Displaying data. Suppose district point. Let me see what data I have. Okay, not from here. Okay, just wait for a minute. It is this is here actually. Local disk. I am showing this lecture. No. Sample disk 0. See. Okay, this is the data set. Okay. Suppose in this data set we open it. You will find, wait for 2 minutes, you will find there are a lot of error data. Let me find you out one. In this data, we have some error data. See, you can see minus 999 error. Okay, can you see it? Yes or no?
Yes, sir. Yes, sir.
Okay, these are because of the age effect. You can see a lot of this type of data are there. Minus 999 error will be there. Okay, a lot of data. I have to find out more also here, and I can show you. There are around 4. See, these are again minus 999. And if you go up there, see, you can again see this. See, you can see this data. So how to remove and solve this data? Because in a data of 10,000, you can't do it manually. Okay. You have to find the values, what are the values are there, how to do this one. Okay. So what happens? I will close this one. Okay. Let's close this one. Then I will visit to this website. That is the I have to visit to my software, from where the software is there. Okay, so my software is here, I think. This one. Okay, I will right click and run it as administrator. Okay, you can run it normal also. There is no issue on that. It will take some time. Okay, the software will take some time actually. So this is an hands-on. You can download this data and you can download this file and you can work on it. Just remember one thing, that while working on it, that the first line and the first row, that you should not have any minus 999 data. Only the first row. Okay. After that, you can have whatever data you have. It will have no problem. It takes some time actually to open, because it is this thing actually. Get the software open. Till that the software is opening, tell me, do you have any question, any problem, any query regarding anything?
Hello, sir.
Yes.
Sir, while working on collab, even in TPU mode, many times it shows all memory has been used, system is crashed. How can we tackle that error?
Okay, that's why I told you, use batch normalization or batch processing. Do it in small patches. It's a tedious work. Do it in small patches, number one. And you will get in a normal collab version, you will get TPU that is of the for only once in an entire day, I think. So convert it to GPU and not in GPU, convert it to normal disk space and memory, and then do it in a patch wise. Okay. So this I just want to tell you that this is the software. Okay. This is the software, and here about you can see the software has been created by me. Okay, developed by Shantan. If you think that I have not created this software, okay, so I just made it there also. So suppose I want to browse the file that the data where it has been problematic. So I am going again to browse the file to the location where the data is there. So it is in the DE education, and 1 minute. Okay, in the hands-on, this is the data that I needed to clear. Okay, so I have browsed the data. See what it is provided. My field is my screen is visible. Yes or no? Tell me.
Yes, sir.
Okay. So the thing is that in this hands-on, you will see that when I uploaded the data, the shape file, it shows that minus 999 counts are per column. In flow, in distance, it is around 45 data are problematic. In flow accumulation, there is 42 data are problematic. In final rate, there are 106 data that is in minus 999 error. In SWD also, storm water, maybe there is a problem around 45. Okay, so I need a clean shape file because I need to use the shape file to do my further processing. So I convert this one to shape file. To choose our output format. So my output format will be in the form of a shape file. Okay. Then I will click on clean data. Okay. See, the data got clean. After cleaning data, there is no missing value left. Okay. Now I will click on show visualization of the data. So I will click on it. So when I will click on it, it will provide, see, all maps saved as PNG in the same folder as your input file. Wherever your input file was there, that is on directly from we have imported, browse the file, it will save all the images there only. Okay, I will click OK. And then it is written export clean file. So I have to provide it where to export the clean file. See, it is in the hands-on there, and I will click here that minus 999 error called data. In which format? In shapefile format, in dot shape. Okay. See, already I use this first I use this was the unclean data. Then I have solved this error and then I saved it. Okay. The file has been exported. Okay. See, it has been provided. The file has been exported to that folder. Now click on open. Now see what happens. So let's go to the hands-on folder. Okay, so this is the hands-on folder. In this hands-on folder, we got to view some of the. Let me show this one in this way. PNG file. Okay. This is the first data that I provided. This is the missing data. See, I have created it now. You can see there a lot of age effect because all these missing data are found in the ages. So these are the missing data. Okay, age data, and then this is the final data check. I have cleaned the final data. Now, if you open this is the final data that I have converted into shapefile. And now, if you open this data, like in the ArcGIS, you will find there is no error. Okay, so with the help of this software, you can easily do it. Am I clear? Tell me. Am I clear?
Yes, sir.
Everyone, it's a very simple software that I have developed for people, those who are non-coders. Okay, you can easily use this. Everyone, just tell me. See, from a geography department, is if I can create a software, you can also do a lot more things than me. Okay, so explore this type of fields, create these product-based things. It will help you a lot. Okay, don't just stick to syllabus and what is being taught, because ultimately the world not runs on how much you have marked up this entire thing. World runs on how much creative, innovative thinker you are. Okay, this is the thing that I want to show as an hands-on. Okay, I don't know whether are you people getting bored or not. So are you people getting bored? If yes, please tell me that also. Okay, are you people getting bored? Yes or no? Please tell me. Please engage with me. Otherwise, how will I understand? Shinchan, what happened? The organizer got bored, I think.
Sir, it is
No,
getting
sir,
good,
we are
sir.
not born.
What happened?
No, sir, it's very interesting session.
Okay,
Sir, from where can I get this software?
you can get it from my GitHub. Okay, just wait for 1 minute. I can provide you that one also. Wait 1 minute.
So you can just provide
I am just sharing you the link in the group actually. You can get the software from here. Okay. Mhm. Okay. I have provided the link. Go and click on the software.exe. It is just you don't need to install the software. Just download it. Run as administrator, or just double click it. It will plug and play like software. It will take some time to open because I have not optimized it. Because I am not a software developer. I have just made this so that you can work on it actually. Okay. So this is the entire thing. Okay, I think you got this one. Okay. Okay. So we will again go to the presentation. Okay, my screen is visible or not? Okay.
Yes, it's visible.
Okay. Okay. Now this is something different that I need to work you with it. This is that with the GEO-AI, I want you to also learn some basics of Python so that you can make a pipeline like this. This is an ERA 5 pipeline data that how we can download a spatial data, hourly data for my location and can work on it. Okay. This is an ERA 5 data that I have downloaded for my location, and then you can see a total time series specification from 2014 or 15 to 2024. Either daily data, okay, total precipitations overs. And you can see these number of data are in the round version. This is the time series analysis of the entire data. Okay, so you can download this type of data. Actually, I just want to show you. I have one, not the hands-on, but I have one entire work of it. Actually, just in 1 minute. I want to show this one. Okay, this is an ERA 5 data. Data scarcity problem. This one. So this is the NetCDF data, how we have downloaded it. This is one example. Okay. So you can detect this one. I just want to show you later also. First, I just want to learn that you can download these data using the pipelines. I have one very good pipeline ready in my GitHub actually. Wait for 1 minute. I want to show my GitHub once again. Okay. So you can download it from there also. Just run it and just see how you can change the locations. Okay. So just wait for 1 minute. What is the repositories? It is a IMAD. It is a ERA 5 data actually. So ERA 5, this one. You can go to this one, ERA file data extraction and post processing. You can download the data, any type of data, precipitation, that is 1 hour, 2 hour, 5 hour, 10 hour data. Okay, you can download that data. Okay, and you can download this code, or the code is given of the entire pipeline. Just download the zip, run the code. This is the code. ERA file post processing data. After downloading the data, how can you do the post processing of the entire data into the Python? Because post processing in GIS software is near impossible, because you can't modify each and everything actually. So you can do it in this ERA file data actually here. You can download it from here. Okay, so this is the thing that I have downloaded from my study area, and in this entire Python you will find this type of work, that how we have downloaded it. And there is one, I think one PPT or something like that is present in this ERA file data. Okay, license, IPM. Okay, all these informations are here. Okay, just go through this information, you can easily get the data. Okay, just download and practice on it. Practicing will help you a lot. Okay. This is another work that one of the candidates was asking. This is the Satara district landscape susceptibility map, and you can see this is the correlation map, the collinearity analysis that I was talking about. This is the correlation code matrix of the heat map that you can create in Python, or you can also put in R software. And this is an innovative pair plot map that you can also see how each and every parameters are related to each other in terms of BIF tolerance, and as well as in terms of the targets. Okay, you can use these two type of things to work on it. This is also a landscape susceptibility map of Satara district. The paper has not been published yet because I was working on a foreign projects on artists, so I worked on this also. Acha. Another important thing, those who are working on the Sundarban region. Okay, this is my ML-based work done by one of my very good colleagues, known as Mr. Arup Vaidya. He's a researcher at the University of Delhi, and he has used deep learning to identify the suitable hotspot zonation of the tourism. So where the tourism can occur, you can find the red areas of the regions where the tourism are very high. So using machine learning and deep learning, you can work on Sundarban region also, or in any other places where you can zonate, symbolize, or you can make a zonation of the maximum tourism hotspot. So see, we are not only working on one field, we are working on tourism sector. We are working on very different sectors we are actually working. So you can also explore this field actually. Okay, how we can use this tourism data, use your brain, explore the ML models according to work on it. So okay, the next part is okay. This is the latest paper of mine that have been published in a journal known as ISPRS, Open Journal of Photogrammetry and Remote Sensing. This ISPRS is the world's top 2 journal. That is, after IEEE, it is ISPRS for the core remote sensing paper. And in this paper, I have developed few new algorithms actually. That is, algorithm is for making a low resolution DEM to a high resolution DEM. Suppose the best open source high resolution DEM that we can get in today's world is Allo's Pulsar, that is a 12.5 meter. So I have converted this Allo's Pulsar into an 8 meter DEM using 2 methods. One, first a void field at high mountain Asia DEM, and converted this Allo's Pulsar DEM into a super resolution DEM using the reference of the high mountain Asia. But first we need to fill the void. So void filling also takes a very different types of advanced state-of-the-art machine learning models, and this entire work is done on the Python actually. I will want to show you how I have chosen the study area. These are the patches, okay, from where I have enhanced the DEM. Okay, so these are my entire workflow that I want to show you, that how you can use computer vision. This is the work of a computer vision. In India, no one works on it. In India, very few people has ever worked on this type of work. All this work are done in China and America only. So only this work we have done from India, and it only took me 3 months to get published. Because it is a good piece of work, and I'm really proud of myself for doing this work. I'm really proud of the supervisor who has helped, because at some point of time when I was trying a lot, I was getting a lot of failures. Okay, I just can't imagine how much failure I've got. I've spent 6 months entirely on this work. Okay, that is also a side part of my PhD, not my entire PhD is defining on it. But at last I got this paper. So you can see that these are all in Python. Someone was asking about selection of the patches in the Python. I have selected these patches in the Python using Python code. You can prompt that code in ChatGPT and ask that I want a code, I want a clickable Python link where each and every patches will be of 64 into 64 pixel or 128 into 128 pixel. and you can get this one. I have made these patches out of that on Python only. So after taking the Python, I have worked on it. I have experimented on this because I can't work on the entire work because as it is a computer vision based work, it takes a lot of GPUs to work. A lot of people will face problem on this. So I use this batch normalization and patching method. Okay, so see, these are the main required that was there in the den, and how I have used this. This model is made by me, CRPAG model is made by me, and these are all models that have been developed by some other people. I have used that models to work on it, and this algorithm is developed by me, CR conditional residual PAG model actually. It's a very good model, you can work on it also. Okay, so it will give you more citations if you want to work on this sort of works. So you can see how this is the main point and how I have filled, how my model has filled the void and how other models have filled the void. Means I have to not only create or develop this algorithm, but I have to also develop code of these pre-trained model algorithms also to prove that how my model has accurately. This is the reference method. You can see how my model has accurately fill the void actually. So this void fill can't be done using a simple method in ArcGIS, made a Python-based method. Okay. So these are some of the graphs that I use in Python. You can see what type of visual representation that we can show in a Python also. That this type of work are needed to be shown that in a very high reputed journal. It is not only the work we are doing, also the visualization also. I will also show you the paper, the work I have done, and see how we have used the main beauty of this machine learning here is that how we are using a DEM and void DEM, and we are filling that void DEM using the data of a Sentinel data. Sentinel is a satellite data. You can see how this satellite data is also helping to give or assisting that entire model to fill the void properly with the DEM values. Okay, this is the beauty of this work. That okay. So these are the architecture. These are my neural architecture. I will show you a basic Python code. That basic, not the entire Python code, which I have worked on it to this one, to void fill one. Okay, so see, this is the original data. This is the data that I provided, and this is how this void has been filled. These are the voids in the data that are present, and how this voids have been filled. And these are the field differences that you can find actually. Okay, so these are the entire thing that you can work on it, and after that, you can see how the normalizing data we have done. These are the Sentinel data. And all these data are visible in the Python, not a single thing is done in the software actually. And these are the algorithms that we have worked on it. Okay, so see, these are the number of voids and Sentinel data, and these are the target patches. How these voids are clear, these noises are clear using machine learning. So these are four remote sensing part you can work on it. And the models that we are using here is an encoder, decoder, generator. These are some of the advanced part of the deep learning models. Okay, so we are not only doing susceptibility map, we are bridging the gaps and filling the gaps actually. So these are some of the most important things that we all need to address. Okay, you can see how we have worked on these patches also. Okay, and these are the results that we have worked on it. Okay, so I will show you paper, and before I will show you the code also. And this is the ultimate day. See, this is the low resolution allows pulsar day. You can see that these days, these regions are a bit coarse resolution. And here you can see a super resolution day that I've created from 12.5 meter to 8 meter, which has a very good resolution. You can see a very good resolution. And when I converted this day in the index 3D model, this is the Chamoli district. Okay, this is the Hathi Parbat. Okay, this is the river flowing. This road is going to Badrinath. No, not this one. This one road is going to Badrinath region. This one. Okay, and this is the entire dam model that I've created. A very high resolution dam of 8 meter resolution. Okay, out of this paper that I have made. Okay, so and we have done a lot of accuracy assessments also for this work. It is not easy to work on it, and I just want to show you one thing, that is the code behind this thing. Okay, so and it is a very difficult task to show the entire thing actually. Let me share this one actually. These are one part because we are not. This is the one part of the entire code I have worked on it. Okay. So let me see whether it is running or not, it is got hanged or not, I will know. See, okay. You can see that. Achha, the code has these are entire not run entirely. It's wait for 1 minute. I just want to run it again. Are you there? Are you people there or not?
Yes, sir.
Hello.
Yes, sir.
Yes, sir. Yes, sir. We are here.
Yes, sir.
I know it is a bit boring, but these are something that no one has done before. So it is always challenging to show this first time things, because what you see in a slide is a ready-made thing. You can see that how it takes page and see the page has become unresponsive. This is the problem. Okay. No issue. I can show it from here also. Why is my anaconda? Okay, this was my anaconda navigator. And I just will launch this one. Sharing with you. Open. I think it has opened here or anywhere like that. It is not opening also. I don't know why it is not opening or why. Yeah, okay, it is open. Actually, wait for 1 minute. My page is visible or not? It is visible, I think.
Yeah, it is visible.
Yes, sir. It's visible.
It will take some time. If you want to see the hands-on on that, it will take some time. But if you don't want to, you can skip it also. So tell me whether you want to see it or not. I have no issue. If you want to see, it will take some time. But if you don't, because these are heavy work, some of the things. Because my laptop is a workstation, but still it is taking time. Means it will take a lot of time. Okay, let this paper get these works get loaded. Okay, it got loaded actually. It will take some time, I know. Too much things are opening actually. Acha. No, it is taking some time, I think. It will take time. I don't know why, but it will take some time. Okay. We can move to next, but I can show you later on. Later on also this one. These are not that much important for you at present because these are some of the very advanced part. Okay, the next this one. This is the NASA iMerge data. How you can download an entire data in your study area and you can make a web dashboard out of it. Okay, so I have created this web dashboard and collected this data from the study area. How you can do is that I have this PDF file. I have also in this thing is also present in the I think it is also present in the GitHub. You can download it from there also. You can see that how the entire code is written. I have written the entire code here. Okay, from where to take the data. Okay, and see here the bounding boxes are given that if you want your study area to be put here, instead of this you can go from here also. You can go to the bounding box data just like this. Bounding box tool. Just take the lat long data from there and you can put it here. It is a very beautiful website actually. Suppose you want to work on this place. Okay. Suppose you want to work on Switzerland. Convert it to the CSV. See, you got this one. 5 degree, 45. You got all this value. Take this value, put on here, and you can easily start start getting the data of your area. Okay, it will give you this much of data, and then it will also provide you this iMerge cell from where you are working with the iMerge NASA data actually downloaded. And after downloading it, I have to extract this post processing. I have created the 3D cells on it so that I can extract the data out of it. And at last, you can see this type of graphs and visualization that I have made. Actually, this is the data from this NASA data. I wanted to detect the cloud burst regions of the Himachal Pradesh that occurred recently actually. So these are some of the recent works that I have actually done, and I have uploaded this in the NASA iMerge. See, if you learn Python, you can do a lot of work in these field of geography. See, and these are the places where these are the days, or these are the places where or sales where the cloud burst has been occurred. Okay, so this is the thing that you can. I have uploaded it. You can see the code. You can just first observe the code, how I have written it, how segment wise I have done it, and then after that you can go to this and you can convert to CSV and this is a bounding box tool. You can get any satellite. You can just make it small. You can create in your own area also. Suppose you want in India. Okay, so suppose this is India and this is New Delhi. You want some rainfall data on New Delhi for data. Just click here and click here in bounding box. You got this one, and see you got the CSV data. Okay, 77 degree east, 28 degree north, 77 degree east, 28.8 degree north. Okay, you can get it easily from there. You can copy this one. You can use it. You got understood this one? You can get any places lat long from here. Okay, you don't need to calculate separately. Got it, everyone?
Yes, sir.
Yes, yes. Okay, good. Okay, so now we will be moving to some of the last part of our work that I want to engage you people. Okay, so this is recently I have done a work on it. So this is an aircraft simulation that I have worked on it, but I have used machine learning here. I will show you the video also. I think that many of you have also learned about this aircraft model that we are doing flood simulation. So basically, what happened? How a geographer can work on this? I will give you a link. Okay, so for example, in any place a flood has occurred. Okay, recently in Mandi flood has occurred. It is on 30th June and on 1st July. Heavy cloudburst occurred and a huge rainfall occurred. So what I have visited this Mandi region, and with the help of some connections of me there, I got the local support and I got some data, unstructured data of in which place of Mandi the cloudburst has occurred, on which place there have been a lot of devastation has occurred. So after that, I made these graphs to showcase you that how I computed the unstructured data into structured data. And after converting the structured data, I founded this area that using the iMerge data, that is this data, I founded out that where the cloudburst has occurred in this cell. And I found in Mandi district, there are in few pockets, a lot of cloudburst has been occurred. And you can see the value of rainfall has gone much higher here. And then I founded that the region Thuna, Thuna is a small village where a lot of rainfall has occurred and it has destroyed a lot of land and property. So see, a normal day river flows in Thuna is like this, but during flood it has occurred like this. So I want to replicate this entire scenario and want to see that what is the velocity, what is the depth, and what is the extent of the river valley that has actually occurred. So I created first a rainfall runoff modeling, and to do rainfall runoff modeling, many people use a HMS model, but I used in Python where I blended the CNN. CNN means convolutional layer CNN based topographic model with LSTM data. LSTM means long short-term memory algorithm. It is a deep learning algorithm where I have used it what is some time series data that downloaded from this pipeline, and then I used LSTM to work on it, and I found the per pixel runoff. After getting per pixel runoff, I used the values in a Haycraft simulation, and you can see how this Haycraft simulation is occurring. You can see that the Haycraft simulation is occurring, how the water is moving from here to here. It is going, and you can see the velocity is going up to 15 meter per second. It's a very high velocity. See how the water is going along the side of the river. It is coming out of the river because the river is very thin. This dark blue color is river, and see how wide is their lateral expansion is during the entire flood scenario. Okay, so with the help of this simulation, we able to find out that how much devastation has occurred because we got the velocity, we got the speed, and we got the impact on the buildings. So in this way, you can work on a geography that you are connecting the ground data with machine learning model, and then with the simulation and providing a real-time data also. So these are the type of work that you can do. This is a simple slide, one-page slide. I have shown everything on it, and you can work on it also in this way actually. Okay, so after that, okay. So before thanking me, I just want to show you one more important thing that that is not part of that is not in the slide. Data scarcity problem. Okay. So this is another last but not the least, another code that I have built. This is also in LinkedIn as well as in GitHub also. That how we have used this geospatial intelligence using AI to fill the gaps and the voids. You can see that there are a lot of data voids that you can see. Again, -999, but these data are complex data. This can't be solved. These are not the age effect. We need to fill this data based on training data. So this is my data area where I need to fill this data and I need to train the data. So I trained this entire data from here and I filled it on here. Okay, you can see I've trained the data and filled this data here, and you can see the locations where the missing values are present. So I converted that missing values here. So I first trained the data and I need to solve it in here also. Okay, so based on the training, the original data was there. We have cleaned that data, and then what we have done is that we have put. You can see the data. There are a lot of data gaps are present here. So using machine learning and deep learning algorithm, you can see this. This is also present in the my GitHub repository. You can find it there also. You can see we have done a training and validation loss, and at last we can got the mean absolute error loss is very less while training, and we got a full data. See the data that has been scarce, I have got this entire data. Okay, see the data that has been minus 999 has converted. We got the capacity and based on the training data. So after that, we made a correlation matrix on that to find out whether number of parameters that are used in meaning the data are correct or not. It has got a very good result actually. Okay, so these are the type of work that you can actually do. Okay, so after that, last but not the least, I just want to tell this one. Okay, this is my LinkedIn profile. You can visit my LinkedIn profile and follow me for more update. I update regularly once and every week. I used to publish something or not. Okay, scans. You can scan this barcode and you can visit or you can directly type my name into LinkedIn and you can connect to me. Okay. So that's for it today. It has almost 2. Okay, so I am stopping my presentation actually. So let me stop the presentation first. Okay, stop my presentation. Okay, so I have stopped my presentation and okay.
There are some questions.
Yes, obviously. That
Yeah.
is the most important thing.
So one question by Rajat Kumar is that, sir, for deep learning, do we need plate cloud services like AWS, Google Cloud, or our laptop with 16 GB RAM is sufficient?
Laptop, see, I'm telling my specification of my laptop. My laptop specification is around 32 gigs of RAM actually. 16 GB is also okay, it is more than enough, but don't overkill it. Okay, don't overkill it. Okay, don't overkill it. It will help you use batch normalization. Okay, just use the batch normalization, it will be more than enough. Okay, just use the batch normalization. That will be more than enough because do it part by part. You can't do anything. I have also faced a lot of problem with my 32 GB of RAM and 12 GB of graphics card. I still face problems sometimes. If you are working on a pixel based, don't do it on the laptop. Do it on PC. But if you want to do on a statistical data, you can do it on laptop. There is no problem. Nothing is that much difficult. Okay, so you can use that also. Any other question? I know there will be a lot of questions. Please tell me. I am there to solve. Okay.
Yeah. So there is one question: is can you please suggest some deep learning algorithms for prediction of LULZ?
See, for LULC, the best thing you can do, according to my experience, go very safe, very simple and easy. Go for support vector machine that is already present in the ArcGIS 10.8. Use that only. That is more than enough. Okay, it is more than enough. You can use that.
So,
and if you want to, and I want to tell one thing that if you want to do a full-scale research on LULC, then you have to collect the sample data from the ground, then train on deep learning models. But if you want to use it just as a parameter, then support vector machine is more.
Okay, so there are no more questions, but some are asking that can you please share your GitHub profile? I mean the profile link.
Okay, the profile, the GitHub. Okay, wait, just 1 minute. Okay, I am sharing the GitHub profile. Just 1 minute. My profile now. Okay, this is the profile. I am sharing both my GitHub and LinkedIn profile in the chat. Just go through it and you can just follow me. Okay, and we can have conversation there also if anyone is having any problem. Okay, I have sent my GitHub and I am also sending you my LinkedIn profile also.
So is there any question?
Yes,
is there any question from learner?
Okay, so before we end the session, we will conduct 2 polls in which we encourage the participant to please engage in the polls to let us know that how you like the session. Okay, so we have just launched the first poll. You can see it from the polls section.
I have provided the LinkedIn profile also. My GitHub and LinkedIn profile both in the chat. You can go and follow me in GitHub. Please follow me on GitHub because it will help me to also grow in GitHub and also will help you to get whatever current work that I will, because I will be present. After a few days, I will be providing 3-4 important 4 topics there also. So you can work on it actually. So, okay, you can do a feedback, but I just want to know from you people also that how do you think that how this webinar is different from the other webinar? I just want to know this from you people. That how this webinar is different from the all other webinars that you have done before, and what impact it has made on you, and how it is different from the other webinar, if it is different or not. I want to know from you. Anyone can tell you.
Hello, sir.
Hmm.
Sir, it was very overview and detailed of hands-on error that we face, as you mentioned about batch processing, then that triple 499 error, and how we can use the global dataset like IMERG dataset, and then ERA5 dataset, and how to use Google Colab and all these platforms and bounding box. That was very, we had to type our lat long before. That was
I
very,
know. That is the problem. That's why I showed you the bounding box.
it was very nice, sir. It very nice. It already met our expectations. Thank you, sir.
So thank you. Actually, it could have been much more interactive, but I was in a very rush hour, just returned from the Ladakh, and I just only got 1 or 2 days, and I also in a rush of submitting one of my manuscripts before going to home for Durga Puja. So it was also a rush for me also. So I couldn't even provide the best of myself, but I provide something that is better. Okay. This is the thing. Any other?
Yes, sir. Actually, we will take their feedback, and I will definitely share with you.
Yeah, you can also
And,
see the feedback, sir, from the poll section. Many of them have voted in the excellent and very good section.
Okay.
Ah.
Why it is?
Yeah,
Poll section. Okay, I got
poll
the poll section.
Yeah, yeah.
Okay.
So
So,
we will be launching the
actually,
second poll. Actually, second poll we will be launching soon. We have just launched the second poll. After you have voted, we can end the session.
Any other question from any candidate if they want
Yeah,
to
yeah.
ask that in human geography perspective or in a see? I just want, okay, I missed something. I just want to show you one more thing that how we have worked on human geography aspect also. Just wait for 1 minute. I will just show you sharing the screen. I just want to show you something that is different that you have never seen before. Okay. So wait.
Hello, sir.
Tell me.
Sir, as for the that census data, we have 2011. In place of census 2011, can I use anything satellite gridded data for population, or we have to go with the census data for socioeconomic?
In India, we don't have a satellite-based population data. No, whatever we are having, that are all wrong data. You can't do anything with that. You have to go for census data only. Okay, or you can do one thing, you can visit the field and collect the data of your work that we have done, that I am going to show you that how we have used AI ML in the human geography perspective. Okay, just wait for 1 minute. Okay, so this is an interactive TSNE map. Okay, so before I just want to give you an example of what happened is that I have visited Bengal in the Rad Bengal region, and I have collected 400 sample data. And with this 400 sample data, they have collected their data using a Tobo toolbox. That is a very good IoT type of thing. It is known as Tobo toolbox. You can download that Tobo toolbox and use data. It will directly save the data in the cloud. And after that, when we are working on the data, I downloaded the entire Excel file of the around 128 questions we have done, and we have around 400 samples, 425 samples actually. So we map each 425 sample with the individual data, individual surveys here. Okay, and you will find that we suppose, for example, there are few people that will not give the correct answer. They provide you the wrong answer. So we have used an AI-based lie detection system that I have made, and I have put it here so that you can see. See, there are 4 things: false positive, suspicious; true negative, suspicious; true positive clean; and true positive suspicious. You can see there, for example, this person. Okay, I have made a probability distribution along with the values, what they have told using a machine learning model. And I have finded out that among 425 people, there are around 365 who has given more or less correct answer, and rest 65 has given wrong answer. You see, in this way, we can purify our data in human geographical perspective also. For the people, those who are going to the field and going giving, and for this one thing is that we have to provide them a close-ended question, not an open-ended question. So, see, we are not only working machine learning on the cohort physical part, but also being on a human part and see how we are advancing that human geographical study using the artificial intelligence. Those who will be working on this, they can also work in this type of field, and we have submitted this paper recently. When it gets published, I will share with you, and it will be a new benchmark for the methodology for those who are working on the quantitative human geography field also. Only quantitative surveying data set also. Okay, you can also work on this. This is an interactive dashboard that we have created, and you can see that. See, for example, I just want to give you an example of this one. See, whether this person is suspicious or not, it is showing false. It is model probability has predicted that whatever he has told is 8.87 is correct, means 87% he has told correct. Okay, but consistency score is 30.13. So consistency is not very high. But for this person, you can see that he has given some result which is some anomaly in it. Anomaly, how we are detecting? We are detecting that few parameters which are in trend. Okay, so in this trend, if one parameter is getting out of the trend, we are conducting as an anomaly. Then see here it is telling that his actual value, what he is telling is 0. That means he is in a non-farm sector, he is in a farming sector. But his probability says that if his farming sector is 0.49, that is less than 0.5. So that means he is telling something wrong. That's why probability has got, the value of probability has got something less than 0.5. So in this we get detecting this person. So see, this is one innovation that we have recently introduced, and this is not easy to work. It needs a lot of statistical measures to work on it. I'm just showing you one interactive dashboard that we have created on it. Okay, so I hope it will give you new ideas to explore on this field also. I know that it is not easy to learn this in one single day. You need 3 years entirely to work and have an experience, and then came out with an idea to provide it in an interactive dashboard format. But we can easily work on that. You can easily work on that after you have enough data and as well as enough experience on machine learning and deep learning, and then connecting with the web GIS platforms. These are the web platforms we make local HTML files and put it there and making it much more interactive, because we can zoom it also and click and we can zoom in and we can see it. Okay, we can zoom it here. We can do anything and everything. Okay, this is the thing. So these are the part that I just want to show you actually. By the way, that's all for today, I think. Okay, just wait for 1 minute. That's all for today. I am stop the sharing. Okay. Do you have any question in this interaction? That one, that human part also, you can work on this also. So you can look on it. This is the thing that we have worked on it. Okay. Any question?
So no questions, but I would like to thank you once again. The session was very insightful. And also, like, AI and machine learning are really fancy terms for beginners like us, and you made us really comfortable with that. So thank you for that.
Okay.
And also the common problems that we go through, and you gave us the solution with like missing value cleaners and the possible projects we can in future work on. And thank you for sharing the codes as well. So
Yes, there's no problem in it.
yes, sir.
Okay, so you are from which university? So just give me a very glance.
I am from Central University of Punjab. I'm pursuing my PhD from now.
Okay, under which supervisor?
So I am working under Professor Sunil Mittal and VK Garg.
Acha, okay.
Yes, sir.
Okay, good, nice. Anyone? Any question? Any other? How can Shilupa? Okay, Shilupa, my student. Okay, the question is, how can I assess the human geograph, like the method? See, you have to this is not a way how you want that human geo, depending on what type of visualization you want to show. For me, we want to show you as a point individual, but proper how human, I exactly don't know now. I also need to explore that field also. But if you want something like this that I have shown it, then it is TSNE map is the most basic way, and it's a very easy way to easy, not easy, a bit difficult, but it is a very good way of representing actually. Okay. No, there is no app in it. I have made it entirely in Python. Okay. It is made in Python using the simple prompts and as well as in some basic JavaScript is not in Python, so you can make it actually. There is no problem in that.
Okay, so we've spent actually more than 3 hours. Okay, so and thank you, sir, for this beautiful and insightful and fruitful session. And hope they have interact very well and adaptive manner. So thank you all for your active participation in today's session. And we explored new tools, techniques, and applications of GEO-AI in machine learning and deep learning. So, as you know, it is a vast and robust subject, so it is quite difficult to know each and everything in this short span of time. So, hope you get an idea from this session, and your encouragement and engagement, your curiosity are making this webinar truly productive. So, we look forward to seeing you in the next workshop so that you can know more and get in-depth knowledge. So upcoming session list will be provided in poll format in group, and you can cast your vote as well. So thank you so much, sir, and thank you so much for all the learners.
Thank you.
Okay, thank you.
Okay. Thank you. Thank you. Bye, everyone. And have a happy Navratri, Durga Puja, and as well as happy Diwali to each and everyone. Okay. Enjoy your day.
Okay. So with the permission of sir, we will now conclude the session. Thank you.
Okay. Thank you.